FD work makes the comparison sharp because it sits between product engineering and customer-facing problem-solving. The roles on this page all touch customers in different ways, but they differ in how much they build, how much they advise, and how close they stay to a specific product. Confusing the role costs time because the wrong hire can look productive while the deployment stays stuck. The point here is not terminology, it is whether work actually reaches production and starts creating value. That expectation is common. A team wants momentum, so it looks for one person who can remove friction fast. The problem is that speed in conversation is not the same as speed in delivery. The ask sounds reasonable because it mixes two needs: technical fluency and customer-facing coordination. But that description still leaves out the hard part, which is driving the solution through the real constraints of a live rollout. That choice makes sense if the main gap is design clarity or implementation planning. It becomes costly when the team expects the hire to own adoption all the way into production. A strong architect can sharpen the requirements and improve the plan, but that does not automatically move the system into daily use. Someone still has to handle environment setup, edge cases, approvals, and the practical work of making the product fit the client's workflow. A deployment-focused operator closes the gap because the job includes the whole path from first demo to steady use. That role is judged by whether the solution keeps working in the customer environment, not just by how good the plan looks. That is why the mistake hurts so much. A mislabeled role creates delays, rework, and missed value. The expense comes from stalled execution, not from a naming disagreement. Role labels can sound clear, while the actual job underneath is much messier. The point here is to separate the title from the kind of delivery work the company really needs. In enterprise AI, teams often use one broad description for roles that look similar on paper but behave very differently in practice. That matters because the hire only works when the job matches the real need. A technical person who can talk to customers may sound like a good fit, but that alone does not say whether the person should only advise, actively build, or own delivery with the client. Implementation can mean anything from answering questions to working inside the customer's environment. The real question is whether the role is meant to guide the work or carry it through. Bridging product and client is often where the confusion starts, because that bridge can be advisory in one company and deeply hands-on in another. The same phrase can hide very different expectations. The hidden issue is ownership boundary, what the person is responsible for versus what they only influence. Once that line is vague, titles stop helping and delivery starts slipping. The easiest way to compare these jobs is by the stage of deployment they are built for. Some roles shape the plan, while others are there to make sure the plan survives contact with reality. A demo or proof of concept answers a narrow question. Can the idea work at all? That stage is about showing feasibility, not about full reliability. A prototype goes a step further by proving the idea in a controlled setting. It still leaves many real-world problems unresolved, so is not the same as a finished deployment. Production is where the standard changes. The system has to be dependable, visible to operators, easy to support, and able to run the same way again and again. Post-launch work is what keeps value alive after the first successful rollout. If nobody owns that phase, the system may look good on day one and then quietly become harder to use or maintain. When a company hires for the wrong point in that chain, the mismatch often shows up late. By then, the team has already spent time, trust, and momentum in the wrong direction. A house gives a useful way to separate advice from ownership. The comparison is simple enough to remember, but it maps well to how these roles behave in real projects. Building a house forces you to think about planning, execution, and long-term livability at the same time. That makes it a clean metaphor for roles that sit between design and delivery. A solutions architect is closest to the designer who helps shape the plan. The focus is on structure, layout, materials, and the trade-offs between cost and functionality, especially when the customer needs a clear blueprint before work starts. An FD is closer to the crew working inside the customer's environment, dealing with constraints as they appear. The job is not just to propose a solution, but to get it working in practice until people can actually use it. That comparison is not a strict rule, but it captures the main difference well. One role advises on the build. The other is accountable for making the build outcome real. The real issue was not technical ability. It was a mismatch between the role and the problem. The point here is to see how that mismatch created friction before the FDE took ownership. Smart people can still be placed in the wrong seat. In this case, the team had capability, but the job being solved demanded a different kind of accountability than the one the role was set up to provide. Those failures showed up in three separate ways, and each one made the delivery path harder to close. The details matter because the breakdown was not one single mistake. It was a pattern. First, the demo looked finished while production was still full of open questions about integration and setup. Second, the role rewarded solution shaping, but the project needed ownership of adoption and delivery. Third, every handoff created delay because no one owned the last mile, so work kept losing momentum as it crossed teams. That is the hidden cost. A bad fit does more than slow one person down. It spreads uncertainty across the whole chain of work, and each extra coordination step adds more delay than the last. An FD-style owner changes the work from a promising demo into a deployment that can actually live inside a customer's environment. The details matter here because that shift touches ownership, rollout, speed to value, and what the product team learns back from the field. Once that role is in place, the differences become easy to spot. The team starts handling the messy parts of real adoption, not just the polished parts of a prototype. The first change is ownership of the jump from prototype to production. That means taking something that works in a controlled demo and making it reliable enough for real use. A prototype can look good and still fail immediately in the field. Permissions, latency, formatting, logging, error handling, training, and approval steps are the friction points that decide whether the system can actually be used. That difference in question is the whole transition. A prototype asks whether the idea is valid, while production asks whether a real organization can depend on it repeatedly without surprises. The second change is that deployment stops being treated as one vague handoff. It becomes a sequence of concrete steps that can be planned, checked, and improved. That sequence matters because each step exposes a different risk. When the path is written out, the team can see where work is actually getting done and where problems are slipping through. Scoping the use case keeps the work narrow enough to solve well. It prevents the team from trying to support every possible workflow before the first one is stable. Instrumentation means building in visibility from the start. You want to know where the system slows down, where it fails, and how people actually use it. Integration is often where the real work lies, because the new tool has to fit the customer's current stack. If it cannot connect cleanly, adoption stalls no matter how good the model looks. Validation on real inputs catches the cases that lab data never shows. That is where edge cases, bad formatting, and unexpected behavior start to surface. A small rollout reduces risk. It gives the team a controlled place to learn before the system is exposed to a wider audience. Monitoring both errors and adoption tells you whether the system is merely live or genuinely being used. A tool that is quiet in the logs but ignored by users has not succeeded. Usage data closes the loop. The rollout improves because the team reacts to actual behavior instead of guessing what customers need. That chain is easy to miss when a team is used to thinking in big milestones. Once the steps are visible, it becomes clear that each one has to work before the next one can succeed. The third change is speed to value. The goal is not just to turn the system on, but to get a meaningful result into the customer's hands quickly. That metric is useful because access alone does not equal value. A system can be technically deployed and still leave the customer waiting too long to see anything useful. In enterprise settings, that gap is often bigger than it should be. An FD shortens it by removing the practical blockers that keep the tool out of the daily workflow. The fourth change is that the organization learns faster from the field. Deployment is no longer just an endpoint. It becomes a source of product intelligence. A strong FD does more than stabilize the rollout. They turn customer experience into structured feedback that product and engineering can use. If the same integration step keeps causing trouble, that is a signal. It usually means the product should absorb some of that complexity instead of leaving it to the customer. Recurring constraints are valuable because they reveal the real operating environment. The product has to fit those limits, not the cleaner assumptions from the lab. When assumptions break in the field, they show where the product story was too optimistic. Those failures are often the best guide to what needs redesign. Some requests are not one-off fixes. They are signs of a missing feature. The FD helps separate temporary support from changes that should be built into the product itself. That feedback loop is part of the role's value. Each rollout teaches the team something real about adoption, and that makes the next deployment cleaner and more useful. This is about a common hiring mistake. The title sounds right, but the job underneath is something else. The real issue is figuring out which outcome the business needs before naming the role. When different people optimize for different goals, the role gets defined by convenience instead of need. A founder may care about growth, while the person writing the requisition may care about approval, speed, or a familiar label. Each person is pulling in a slightly different direction, so the final job title becomes a compromise. That is how a company ends up hiring for a description that sounds workable on paper, but does not match the work that actually needs to get done. Once the wording gets vague, the first job is to separate the possible functions. The phrase sounds simple, but it can hide very different kinds of work with very different skill sets. That version is about making the product understandable and easy to evaluate. The person in that seat turns a technical offering into something customers can grasp and trust. This job is closer to rollout and execution. The focus is not just explaining the product, but getting it used in a real environment and removing the friction that slows adoption. This one is about keeping current customers healthy. The work centers on solving issues, maintaining confidence, and preventing churn rather than building the initial case or driving a fresh rollout. Those three jobs can overlap, but they are not the same role. If you hire for the wrong one, the person may be excellent and still fail to produce the outcome the business actually needs. The metric tells you what behavior will be rewarded. If the team rewards alignment, it tends to value persuasion and stakeholder management. If it rewards adoption, it needs someone who can deliver real usage and change the operating state of the product. Role names are often fuzzy, so a simple comparison test helps separate them by responsibility and incentive. The goal is to tell apart roles that sound similar, but sit at different points in the customer journey. When a title does not tell you much, the safest move is to inspect the work itself. These questions focus on who owns the customer path, who shapes the solution, and who stays attached after launch. Each question points toward a different role. Ownership of the path into production sounds like an FD, scope and technical design point toward a solutions architect. Pre-sales fit points toward a solutions engineer, and post-launch account management points toward a technical account manager or customer success role. The categories are not airtight, and real companies blur them. Even so, the pattern is useful because it gives you a practical way to interpret a job title instead of trusting the label alone. The stronger test is incentives. If the role is measured on revenue influence or deal support, it behaves very differently from a role measured on deployment success or adoption, and that difference often matters more than the title. Current job postings show how the title is used in practice, and that matters more than guessing from the acronym alone. The goal here is to read the market the way a hiring manager does. Title, location, responsibilities, and compensation disclosure all carry signals. Two OpenAI listings make the distinction easier to see. A forward-deployed engineer points more toward embedded deployment and customer-facing implementation, while a forward-deployed software engineer suggests the same setting with heavier software engineering expectations. That is why the acronym by itself is not enough. A practical reading starts with what the role is actually expected to do, then checks whether the work leans more toward deployment, customer integration, or core software building. The table turns that into a checklist. Title and location tell you a lot, but compensation may be unpublished, and seniority often hides in the responsibilities and qualifications rather than in the job title itself. This is the main market lesson. If pay is not listed, state that clearly instead of inventing a range, because the missing range tells you something about the employer's disclosure habits, even if it does not tell you the salary. For searching, use the exact titles first, then widen to nearby labels like Solutions Engineer, Implementation Engineer, Customer Engineering, or Technical Account Manager. Those keywords help you find the right roles, but the responsibilities section is what decides whether the job is truly FD-like. OpenAI is a good example of how similar job titles can hide different ownership. The name may sound close from one posting to another, but the work can shift between customer deployment, operational problem solving, and core software ownership. A title family can point to a split in responsibility even when the wording looks nearly identical. One role may live closer to the customer and the deployment environment, while another takes on more direct engineering ownership inside that deployed system. That means the title alone is not enough. The real signal comes from the tasks the role actually owns, especially whether it's doing the work itself or mainly advising, supporting, and coordinating around it. Implementation means hands-on delivery, writing, building, and changing the system. Advice is different. It can be valuable, but stops short of owning the artifact itself. Production rollout means getting a system into real use and handling the messy details that come with that. Support-only work stays adjacent to the rollout, helping people use it without owning the deployment end-to-end. Customer-side debugging focuses on problems in a live environment, often with specific constraint from a client. Internal product development is earlier and broader, shaping the software before it reaches that environment. That final contrast matters because it separates finishing work from originating work. One role may be about helping something actually take hold in practice, while another is about shaping the solution at the start. A mislabeled role shows up when the title says one thing, but the work, the interview process, and the incentives point somewhere else. The goal here is to read past the title and identify the actual shape of the job. A mismatch across those three signals is the warning sign. When the description, the hiring loop, and the reward structure all point to different expectations, the role is usually carrying more than one job. That kind of gap usually means the company says it wants execution, but it is screening for design thinking instead. A true deployment-heavy role should test the messy, practical details of shipping, not just the elegance of the architecture. If the team is really spending time in live customer environments, the role needs hands-on debugging skill and patience with operational issues. A pre-sales profile leans more toward persuasion and solution shaping, which is a different mix of work. That tells you the company may value the outcome it talks about, but pay people for a narrower business metric. When adoption drives success, the role should usually be measured on usage, retention, or implementation quality too. When both responsibilities sit on one person without being named, the job is broader than the title suggests. That often creates hidden trade-offs between technical delivery, client management, and internal coordination. On the candidate side, the same pattern shows up in the language of the posting. Phrases that mention implementation, production rollout, and close work with clients usually point toward a forward-deployed style of role. That phrase usually means the person is responsible for getting real customers live, not just advising from a distance. It points to ownership of the hard part where the product meets the customer environment. Production is the key word there. It means the role is not about prototypes alone. It has to make something stable, usable, and deployable in the field. That usually signals hands-on integration work inside the customer's constraints. You're dealing with their systems, their processes, and often their deadlines, which changes the nature of the engineering work. Ownership of rollout means carrying the last mile from internal readiness to external success. It is a strong sign that the role combines engineering with implementation responsibility. That phrase shows the role sits between customers and the core product team. It listens to what breaks in practice, then feeds that back into the product so the next version fits real usage better. Those keywords help you find roles with a similar shape, even when the title varies. Treat them as search signals, though, because the actual job still depends on the interview process, the deliverables, and what the team expects day to day. The hiring choice should follow the job the company needs done first. When the urgent pain is deployment, solution framing, or post-sale support, the wrong first hire slows everything down. When the immediate problem is getting a product live in a customer environment, the first priority is someone who can carry that deployment all the way through. Technical explanation helps, but ownership of the rollout is what removes the bottleneck. When the hard part is shaping the solution and qualifying whether it fits, a solutions architect or solutions engineer can be the better first move. That role is strongest before implementation, where the main work is turning a messy need into a clear technical path. Once the customer is already live, the pressure changes. At that stage, a TAM or post-sales engineer is often the better fit because the work is about keeping the account stable, solving issues early, and protecting adoption. That comparison matters because different roles solve different problems. If a team pays for one kind of expertise while needing another, time and money get wasted on the wrong shape of support. Anyone who can explain that distinction in plain language already understands the life cycle well enough to avoid costly confusion. After that, the next step is drawing the boundaries of ownership so the role matches the work instead of drifting into overlap. Ownership is the cleanest way to separate these roles. One role carries the work through production and stays accountable for the result. The other shapes the solution so someone else can operate it successfully. The same confusion appears from both sides. A company trying to hire the right person and a candidate trying to understand where their skills fit. Both questions are really asking who carries responsibility for what. When a founder asks this, they usually want someone close to the customer who can turn an AI idea into something live. The answer depends on whether the main need is system design and coordination or hands-on delivery inside the customer's real environment. That candidate is asking the more important question. The best fit is not just about liking clients or liking building. It is about whether the role is expected to carry the implementation all the way to a working outcome or hand off a design for others to run. That difference matters because accountability changes the job. An FD is measured by whether the customer actually succeeds in production, while a solutions architect is measured by whether the proposed design is sound, clear, and usable by the team that will execute it. Real projects expose the gap between a good plan and a working system. The architect may define the shape of the solution, but the FD has to deal with messy data, permission mismatches, broken edge cases, and the extra integration work needed to make the rollout succeed. Blueprint versus construction separates planning from making. The contrast matters because enterprise work often fails not at the design stage, but when real systems, real people, and real constraints enter the picture. A custom home makes the difference easy to picture. One person can design the plan from far away, while another has to deal with the actual ground, materials, and surprises on site. A solutions architect focuses on the overall design and the intended shape of the solution. The work is about setting direction, making trade-offs, and producing a plan that can be handed off cleanly. An FD works much closer to the actual environment, where assumptions get tested immediately. Soil conditions, concrete, and unexpected gaps in the plan all stand in for the messy details that only appear during implementation. A design can look complete and still fail in practice because the real world does not match the drawing. Older systems, messy data, stricter security, and unplanned workflows all force the solution to adapt instead of simply following the original plan. At that point, the role changes from designing for approval to taking responsibility for outcomes. The important question becomes whether someone will stay with the work until the environment and the plan actually fit together. A solutions architect can stop after delivering a sound design, but an FD cannot. The job is to keep testing, adjusting, and solving until the plan still works when it meets the customer's reality. This part separates the FD's contribution from the work that happens before and after it. The important shift is from planning and assumptions to hands-on implementation, adoption, and product feedback. Those four questions give a clean way to judge the role. They move from the original problem to the change the FD made to whether people actually used it, and finally to what the product team learned from production. The sequence matters because it shows the full loop of field work. A good FD story does not stop at delivery. It shows the gap that existed, the fix that was applied, evidence that real users adopted it, and the insight that returned to the product team. A simple comparison makes the role easier to see. On one side is the pre-work, defining the target and the handoff. On the other side is the field work, finding friction, shipping the fix, and proving it matters in real use. The table shows a useful contrast between a solutions architect and an FD. The architect leans toward design and handoff, while the FD stays closer to the customer environment, where the real integration problems, usage patterns, and reliability issues show up. That gap is the center of the job. It is where messy data, implementation details, customer communication, and product judgment all have to line up before the solution becomes real. The T-shaped model explains why this role needs both depth and range. One strong technical core keeps the work grounded, while broad skills let the person operate across the rest of the customer and product workflow. The vertical stroke of the T is the deep specialty, and the horizontal stroke is the working knowledge that reaches into nearby functions. That combination matters because the role has to solve hard technical problems without losing sight of the people and processes around them. For an FD, the technical side has to be strong enough to build, debug, and integrate real systems. The broader side covers how the customer thinks, how the product fits the use case, and how to work smoothly with sales, support, engineering, and operators on the customer side. That broader reach is what makes the role more than a translation layer. The person is checking assumptions in real use, hearing the gaps between what people say and what they do, and sending back feedback that engineering can actually use. A solutions architect can also be highly technical and customer-facing, so customer contact alone does not define the distinction. The real difference is ownership. One role owns the design choice and explains it, while the other owns what happens when that design meets the real world. This part shows the gap between a clean plan and a real deployment. The point is to see why the person who owns the rollout needs to work inside the customer's environment, not just design from afar. A rollout like this sounds straightforward on paper. Connect the model, give it knowledge, and expect the team to use it. In practice, the surrounding systems and daily habits decide whether it actually helps. The architect builds the intended shape of the system, what data the assistant can see, how it retrieves approved material, who is allowed to use which parts, and who will implement the plan on the customer side. That creates a solid starting point, but it still assumes the environment will match the design. At that moment, the real test starts. A design only matters once it meets the messiness of production systems, human workflows, and incomplete data. The customer environment rarely matches the neat assumptions from the design. Old documents, mismatched permissions, and a support workflow that already has muscle memory can make a good prototype look unreliable the moment people try it for real. That is the point where the field engineer becomes essential. The role is not just to observe the problem, but to reshape the deployment so the system works in the customer's actual setting. First, the documents need to be made usable. Normalizing names, formats, and versions gives retrieval a trustworthy foundation instead of feeding it a pile of inconsistent files. Then the retrieval layer has to fit the actual content and access rules. Small changes there can determine whether the assistant returns the right answer or misses the important source entirely. Instrumentation turns the pilot into something measurable. Instead of guessing why users struggle, the team can see which tasks complete, where they stop, and which patterns repeat. The assistant also has to live inside the work people already do. If support agents copy snippets into tickets, the tool has to support that motion rather than force a new habit that slows them down. Finally, the failures become product feedback. That closes the loop between customer reality and the next release, so the system improves instead of staying frozen after launch. The shift is from a plan on paper to a system that people actually use and that can be evaluated with evidence. Measured adoption matters because it shows the assistant is not just present, but useful in practice. That boundary is the clearest way to separate the architect's role from the field engineer's role. One shapes the intended solution, the other makes it work inside the customer's world. The point here is to separate responsibility for planning from responsibility for delivery. That boundary matters because it tells you who owns the idea on paper and who owns whether the work actually succeeds in practice. Keep one rule in mind. The role is defined less by where the work starts and more by what outcome that person is accountable for. That distinction becomes the simplest way to compare the two jobs. A solutions architect is judged by whether the plan is sound, complete, and technically right before execution. An FD is judged by whether the final result works for the customer in the real world, after all the messy details are handled. Once outcome becomes the standard, the work stops fitting neatly inside one specialty. You end up touching implementation, data, communication, and even how different teams measure success, because all of those pieces affect whether the result lands well. The FD may need to move across the whole stack, from front-end behavior to back-end logic to integrations and deployment. That breadth matters because a customer problem rarely stays inside one layer of the system. Enterprise data usually arrives incomplete, inconsistent, or shaped for some older process. The FD has to clean and reshape it so the solution can actually use it. The customer's real workflow often differs from the workflow described at the kickoff meeting. Good discovery exposes that gap early, and clear communication keeps the implementation aligned with how people truly work. Different teams care about different outcomes, so the implementation has to create value for all of them at once. An FD has to make the work make sense for sales, product, engineering, and the customer, not just for one side. The metric that matters most may be usage, completion rate, fewer escalations, or time saved. Approval alone does not prove success. The real question is whether the solution changes the work in a meaningful way. Mislabeling happens when the title sounds one way, but the actual ownership looks different. The job title can be misleading, so the real test is what the role is responsible for end to end. A company may use a familiar title to attract applicants, while the day-to-day work tells a different story. One role may be called Solutions Architect, but spend time on deployment and debugging. Another may carry the FD label, but focus on presentations and partner support instead of hands-on delivery. That matters because the comparison is not about naming style. It is about who owns the outcome and how far that responsibility extends. A useful way to separate the roles is to ask where the job actually stops. The end point of responsibility tells you much more than the title on the posting. When the work is done, once the customer approves the design, the role is leaning toward architecture ownership. The focus is on agreement, structure, and technical direction, not on carrying the system all the way into daily use. when a responsibility continues until the system is running successfully in production. The role is much closer to an FD. That means the job includes implementation, troubleshooting, and making sure the customer can actually rely on the system. Role titles in this area shift fast. So the useful skill is reading the market as a set of signals rather than trusting a fixed label. The goal here is to learn what different titles usually imply about ownership, customer contact, and technical depth. A company may rename the same work from one posting cycle to the next, so the title alone can mislead you. Treat the title as a clue for where to search, then confirm the actual responsibilities in the posting itself. The examples that follow should be checked against live postings, because compensation bands and level expectations move quickly. What matters is the pattern in the role names and the kinds of ownership they usually signal. A posting can change enough that an old screenshot becomes misleading, especially for title, level, and pay range. The safest approach is to verify the exact role name and the current posting text before using it as evidence. These titles cluster into two broad patterns. One group leans toward deployment and customer-side implementation, and the other leans toward architecture and solution design. The exact wording matters because it often reveals whether the role is about shipping systems into a real environment or advising on how those systems should be shaped. When titles vary, search terms become the more reliable entry point. These phrases tend to pull up postings that involve implementation, rollout, and close contact with customers. That wording usually points to work where you are responsible for making a customer deployment succeed, not just handing over a design. Expect implementation details, coordination, and some practical problem solving in the field. This phrase suggests the gap between a model that works in a notebook and one that survives real use. The posting will usually care about reliability, integration, and the steps needed to operate the system safely at scale. That language signals customer contact, so the role probably includes communication as part of the technical job. The person in the seat is expected to translate requirements, answer questions, and keep progress moving with the client. Ownership language matters here. If a posting says you own the rollout, the company expects you to carry the implementation through launch and deal with the issues that appear along the way. That phrase points to a role sitting between internal teams and customer needs. The work is often collaborative and feedback-driven, with repeated adjustments rather than a one-time handoff. A customer environment adds constraints that do not exist in a clean demo setup. Compatibility, access, security, and messy real-world data all become part of the job. Enterprise deployment implies larger systems, more stakeholders, and more process around release and support. The role usually asks for enough technical range to work through integration and operational concerns, not just prototype features. Post-sales ownership means the work continues after the contract is signed. That usually brings a mix of implementation, support, troubleshooting, and keeping the customer successful after launch. The same seniority label can hide very different expectations depending on whether the role is centered on architecture or on deployment. Reading the ownership model gives you a better sense of both pay structure and the kind of experience the employer values. A solutions architect role usually rewards breadth, communication, and the ability to shape a plan before anything is built. The posting often looks for people who can explain trade-offs, guide decisions, and work well in front of stakeholders. An FD role usually looks much closer to implementation ownership. The posting often expects someone who can code, diagnose problems, adapt quickly, and keep moving when the environment is unclear. Years of experience can appear in both kinds of roles, but the signal is not the same. In an FD posting, the employer is often testing whether you can carry real delivery work under pressure, not just speak about the system at a high level. The cleanest reading comes from the action words in the posting. Verbs about designing, explaining, and handing off usually point toward solutions architect work, while verbs about building, adapting, and pushing through production usually point toward FDE work. Ownership shows up most clearly in the incentives around a role. When you track what people are rewarded for, the real boundary between design responsibility and outcome responsibility becomes visible. Titles and handoff points can be misleading, but incentives usually reveal the truth. What a role is measured on tells you what that role is really expected to carry. When a person is judged on proposal quality, technical unblock work, and getting architecture signed off, the job is centered on shaping the solution. That points to ownership of the design itself, not the long-term result after delivery. When the scorecard includes post-launch success, stable production behavior, adoption, and product feedback, the role reaches past the handoff. That kind of measurement means the person owns whether the customer actually succeeds with the result. That matters because measurement drives behavior. A role may sound like engineering, but act like pre-sales if everything ends a handoff, and a role may sound like architecture, but operate like field support if success is judged in production. A title gives you the first clue, but it does not settle the question. Real responsibility only becomes clear after you look at where the incentives sit. The better question is who owns the outcome and under what conditions. Once that is clear, the role definition becomes much less ambiguous. An FD remains attached until the customer is successfully using the solution in production, while a solutions architect is mainly responsible for the design that gets handed off. That boundary is the cleanest way to separate the two roles. And the next question is how much coding happens on each side of it. Coding intensity and timing separate these two roles in practice. The important question is not only who knows the system, but who keeps building when the customer process gets messy and the work has to survive real use. One candidate spends more time turning a customer problem into a clear proposal, getting alignment, and earning technical buy-in. The other stays close to the implementation itself, fixing integration issues and making the model usable in the customer's environment. That difference changes the shape of the job. A role can sound advisory at the start, but the real distinction is whether the person leaves after the handoff or keeps carrying the work until the system is live and stable. A solutions architect is usually strongest in the early phase when the solution is being shaped and approved. A forward-deployed engineer is optimized for the hard part after the handoff, when rollout, debugging, and operational edge cases decide whether the product actually works. The main difference comes down to where the work sits relative to adoption. One role helps shape the sale and the design. The other helps make the product survive real use once the customer is already committed. A solutions architect usually works at the boundary between the customer's goals and the product's limits. The job is to turn needs into a design that feels credible enough to support a purchase, a rollout plan, and the technical review around it. A forward-deployed engineer appears later, when a customer has already committed and the messy details start matching. The question shifts from whether the solution looks viable on paper to whether it can handle production constraints, exceptions, and surprises. A simple comparison makes the roles easier to remember. One is focused on getting to yes. The other is focused on making yes hold up under real-world conditions. The solutions architect reduces uncertainty before adoption. That means clarifying the architecture, spotting risks early, and helping the customer feel confident that the proposed path is feasible. The forward-deployed engineer works inside the adoption process itself. The emphasis shifts to implementation, adaptation, and stabilization while the system is being pushed into a live environment. That split affects everyday work very directly. The architect tends to live in diagrams, discovery meetings, and decision documents, while the engineer spends more time in code, integrations, debugging, and measures of whether the system is actually working. The daily shape of the job matters because it separates the roles in practice, not just in title. The biggest difference is where the time goes, and that changes the kind of problems each person is expected to solve. A forward-deployed engineer is usually much closer to the implementation work, so coding can dominate the week. A solutions architect still touches technical work, but the job is usually split across meetings, planning, documentation, and coordination, so the IDE takes a smaller share. Those percentages are only a rough pattern because company structure and product maturity change the balance. Even so, the gap is wide enough to affect what each person sees first, what they can repair quickly, and who gets pulled in when production starts to fail. The easiest way to feel the difference is to compare the same customer journey through both roles. One role spends more time shaping the solution early, while the other stays closer to the system as it gets built, shipped, and stressed in real use. In pre-sale, the architect is usually the one shaping requirements and explaining the design, while the FD may only advise. By rollout and production, the pattern flips. The FD is writing code, handling edge cases, and owning stability with customer feedback, while the architect is more often in a consultative role or feeding lessons back into the product team. Picture a timeline from the first sales conversations to life in production. The architect's influence is strongest early, then tapers as implementation begins, while the FD starts later and keeps going into the customer's real environment, where the abstractions either hold up or break down. The roles make more sense once they are tied to a real build. A custom home gives a clean way to separate planning from on-site execution, which is exactly the difference between these two jobs. A house project is a good mental model because everyone can picture the stages. First you agree on the design, then you deal with the realities of construction. That same split helps clarify how the two roles contribute at different moments. The architect works before the build becomes messy. Their job is to turn open-ended needs into a plan that the buyer and contractor can both follow, so the team avoids expensive misunderstandings later. The engineer on site deals with the ground truth. Once real-world constraints show up, the job shifts to making the system work anyway, even if that means reinforcing the foundation or rerouting a line. That timing explains why the two roles show up at different points in the customer journey. One helps decide whether the fit is right, and the other helps make sure the chosen solution survives real use. The important shift is from technical promise to operational reality. The real question is what blocked adoption before the FD arrived, and what changed once the work moved into a live customer environment. Those four questions make the role concrete. They force you to look at the starting problem, the system changes, the adoption signal, and the product knowledge that comes back from the field. Each question isolates a different part of the job. The first exposes the real failure mode. The second shows the intervention. The third proves whether users accepted it. And the fourth tells you whether the company learned from the deployment. A concrete customer story turns the abstract role into something observable. Once you put the work into a messy production setting, the boundaries between design, implementation, and iteration become much easier to see. A clean demo can hide all the hard parts, messy taxonomies, inconsistent tools, and resistance from the people who actually use the system. The solutions architect may frame the architecture, but the FD takes responsibility for the rollout details that make the assistant usable, measurable, and worth trusting. That contrast matters because guidance stops at advice, while ownership reaches into the live system. Operational ownership means the deployment keeps getting adjusted until it works in the customer's environment. Before the FD steps in, the product may look sound on paper, but still fail in practice. Adoption is stuck because the design has not yet been shaped to the customer's real workflow and constraints. After the FD works on it, the system fits the workflow more closely, gets monitored in production, and improves from actual usage signals. That is the difference between a setup that exists and a setup that keeps learning. The company gets more than a working deployment. It learns which assumptions were wrong, which edge cases keep showing up, and which custom fixes should eventually become part of the standard product. That feedback loop is the real payoff. A strong FDE turns a one-off recovery effort into knowledge the product team can use on the next deployment. And that is what makes the role matter beyond a single customer. Ownership boundary and incentive alignment explain why two similar-looking roles can behave very differently. The real question is not the title alone, but which stage of the customer journey the person owns and what outcome they are rewarded for. When a role owns a boundary in the life cycle, its incentives naturally shape the work. That boundary tells you where responsibility starts and stops, and the incentive tells you what kind of behavior gets prioritized inside it. A solutions architect is often judged by how well the design conversation goes. Does the customer understand the architecture, trust the approach, and agree to the plan? An FD is usually judged later by whether the system actually works in the real environment and the customer can use it successfully after launch. Those measures reward different kinds of behavior. One emphasizes alignment before deployment. The other emphasizes adoption and results after deployment. For a solutions architect, the useful signals are clarity in the plan, technical feasibility, stakeholder alignment, and a clean handoff to the next team. Those metrics fit a role that needs to reduce uncertainty and help people commit to a direction. For an FD, the signals shift to deployment completion, real adoption, system reliability, issue resolution, and the lessons captured from field. That tells you the role is accountable for what happens after the system leaves the slide deck and enters production. A title can hide the real job. Someone with one label may still be acting like a pre-sale advisor if the incentive stops at the demo, while another person with a different label may be carrying FD responsibilities because they own rollout and production outcomes. The lifecycle stage and a metric define the role more accurately than the name on the badge. Mislabeled roles usually hide in the verbs and the ownership boundary. The goal here is to tell apart a pre-sale advisory job from a hands-on delivery role by reading what the posting expects the person to actually do. A posting often reveals itself through action words. If the verbs point to advising, scoping, and handing off, that suggests one kind of role. If they point to building and operating, that suggests another. The fastest way to compare roles is to group the language by the kind of ownership it implies. Once the verbs are separated, the title starts to mean less than the work described under it. Words like these point toward pre-sale or solution-adjacent work. The person is shaping the plan, helping the customer evaluate it, and then passing the work along rather than carrying it through full production ownership. These verbs describe a deeper delivery role. The work continues after the first meeting through integration, rollout, debugging, and long-term reliability, which is a very different kind of responsibility. Current titles can be inconsistent across cities and companies, so the title by itself is not enough. A role may sound similar on paper, while actually demanding very different amounts of coding, customer-facing work, and end-to-end ownership. So the safest reading comes from the full combination of title, verbs, level, and stage of responsibility. Job seekers can use title variants as search terms, but the search is only a starting point. These labels often cluster around the same family of hybrid customer and engineering roles, even when the exact duties differ from company to company. This phrase often points to a role that sits close to the customer and close to the product, with enough technical depth to ship real work on-site or in the field. When the word software appears, expect more direct coding responsibility and more emphasis on shipping and adapting software in the customer environment. This title often signals a bridge role. The engineer works with customers directly, translating needs into technical solutions and keeping the implementation on track. That label usually suggests applied model work tied to a business use case, where the role is less about research and more about making AI function in practice. This usually means the job centers on rollout and adoption. The engineer helps a product fit a specific customer setting and keeps the deployment moving. A solutions architect title leans toward design and system shaping. In an AI context, that can mean framing the architecture, guiding decisions, and coordinating the technical approach. A consultant label usually means advisory work first. The role may be technical, but the center of gravity is often diagnosis, guidance, and customer-facing problem-solving. The real signal comes from the description and the conditions around it. If the posting emphasizes demos and architecture review, it leans pre-sale. If it emphasizes rollout, iteration, and customer-specific build-out, it leans delivery. Compensation, experience level, location, visa rules, and seniority bands all add context. But the role is best understood by reading the whole posting as a map of responsibility. This shortcut helps separate two roles that often get mixed together. The real difference is whether the job ends at winning the deal or continues through making the customer succeed after the deal. A single screening question can save a lot of confusion early on. It forces you to ask what kind of outcome the person is actually responsible for, instead of judging only by title or surface skills. The first case points to someone who supports the sale. They help shape the solution, answer concerns, and give the customer confidence to commit. The second case points to someone who stays close after the decision, translating the product into working reality inside the customer's environment. The edges can overlap, and good teams often blur them. Even so, one role leans toward convincing people the design is sound, while the other leans toward getting the system installed, integrated, and actually useful in practice. The useful distinction is simple. One role focuses on reducing uncertainty before the handoff, and the other focuses on reducing uncertainty once the system is live. That difference shapes every part of the job that follows. A solutions architect spends more time shaping the plan, validating the approach, and clearing risk before work reaches the customer. An FD spends more time inside the code base and the production environment, making the deployment hold up under real conditions. Once that focus shifts, everything around the role shifts too. Who owns the problem changes, what counts as finished changes, how much implementation work is expected changes, and the measures of success change with it. The same pattern explains why the roles can look similar on paper, but diverge in how they are rewarded. The next step is to separate the incentive structure from the job title itself. The difference comes down to where the person creates value in the customer journey. One role helps close the sale. The other helps make the product actually work after the sale lands. These job titles overlap on the surface because both people talk to customers, show the product, and sometimes write code. The overlap can make them look interchangeable, but the real distinction is in the job they are hired to do. That question cuts through the title game immediately. A strong hire is not defined by how impressive the role sounds, but by the outcome the company expects from that person. An SE is usually part of the sales motion, so the work is tied to persuasion, evaluation, and getting the customer to say yes. An FD is closer to implementation, where the hard part is adapting the product to real systems and making adoption succeed in production. Job titles can be misleading, but the reward system usually reveals what the role really does. The goal here is to separate the label from the work the company actually values. In enterprise software, words like solution, customer, field, and technical get reused in different ways, so a title alone does not tell you much. One company's engineer may spend the week on demos and presentations, while another's similar title is doing deeper technical work. The better question is what gets measured and rewarded. If you know what drives compensation, promotion, and recognition, you usually know what the role is optimized to produce. A sales engineer usually supports the deal before signature. The work leans toward helping sales move opportunities forward, clearing objections, and making the customer confident enough to buy. A forward-deployed engineer is usually judged after the sale, when the software has to work in the customer's environment. The focus shifts to adoption, reliability, and whether the system is delivering real operational value. That difference matters because people tend to optimize for what they are rewarded for. If the reward is tied to revenue conversion, the role pushes toward helping deals close. If it is tied to deployment success, the role pushes toward making the product work inside the customer's actual workflow. This part separates two roles by timing and responsibility. The key question is whether the work is aimed at winning trust before the sale or making the system succeed after it reaches a real customer environment. A live customer problem becomes much clearer when you ask what was broken, what changed, how adoption was measured, and what the team learned from the rollout. Those four questions show both the technical work and the business outcome. Each question pulls out a different stage of the work. The first two focus on the problem and the intervention, while the last two show whether that intervention actually survived contact with production and produced useful feedback. A side-by-side comparison makes the split easier to see. One role is centered on proving feasibility before commitment, and the other is centered on making the solution work inside the customer's real operating conditions. On the left, the work supports evaluation, demos, proofs of concept, and technical validation that help close the deal. On the right, the work becomes implementation, integration, workflow changes, hardening, and measuring whether people actually use the system in production. The important divide is not coding skill. It is which stage of the customer journey the person is expected to move, and whether their success is judged by helping the sale happen or by helping the product stick in real use. This comparison makes the difference between sales engineering and forward-deployed engineering much easier to feel. The point is to separate the person who helps win the deal from the person who helps the system work in the customer's real environment. A sales engineer helps the buyer picture the solution, answer objections, and decide whether the house can be built at all. A forward-deployed engineer comes in when reality gets messy. The site, the wiring, the appliances, and the custom constraints all need adaptation. The sales motion is about creating confidence before purchase. The work is shaped around clarity, persuasion, and a convincing demonstration of value. It starts with interest, but also with doubt. The prospect needs to see something concrete enough to believe the product can solve a real problem. That is where the sales engineer builds a polished path through the product story. The demo, prompt, or prototype is designed to make the idea easy to grasp quickly. At that moment, the buyer is not asking for full production readiness yet. The main result is belief that the solution has real potential. That kind of confidence helps move the conversation forward. The output of the sales engineering effort is momentum in the deal. The forward deployed side begins after commitment, when the easy version of the solution has to become the working version. The challenge shifts from proving value to surviving the customer's actual constraints. The purchase is complete, but the hard implementation work is just beginning. A signed deal does not mean the system is ready to run in production. Real environments rarely match the clean version shown earlier. Data quality, access control, and process gaps force the team to rethink how the solution actually fits. This is where the forward-deployed engineer earns the name. The job is to change the plumbing, strengthen weak links, and reshape the implementation so it can hold up under real use. Success means the system produces value where the customer actually works, not just in a demo environment. The implementation has to survive the daily realities of that business. That contrast captures the relationship neatly. One role builds confidence and vision. The other makes the solution usable under real conditions. Quota language separates a genuinely technical field role from a role that is being managed like sales. The title can sound similar, but the metrics usually tell the truth. In this sample, none of the FDE postings tied the role to a sales quota. That does not prove every market works the same way, so the number needs a fresh check against current postings before anyone makes a hiring or publication decision. Once a posting starts using sales-style language, the label deserves scrutiny. The words themselves often reveal whether the company expects field engineering work or seller behavior. A quota means there is a number to hit, and that usually changes the whole job. When a field role is judged by quota, it stops looking like pure technical support and starts looking like sales. Territory language suggests assigned accounts or regions, which is another sales signal. Technical field roles may cover customers, but a formal territory often comes with ownership and target pressure. Pipeline points to deals being tracked through stages, not just problems being solved. That language usually means the role contributes to revenue flow, which pushes it closer to a selling function. Forecasting is a sales management activity when it is tied to expected bookings or revenue. If the posting cares about forecast numbers, the role is probably being measured with commercial outcomes in mind. Bookings are direct sales output, not technical adoption. When a role is tied to bookings, the company is telling you that closing revenue matters more than independent field engineering work. A revenue target is the clearest sign of all. Once a role is measured by revenue, the job description is no longer describing a pure FD function. So the label alone is not enough. The incentive structure matters more because a company can call the role an FD while still organizing it around commercial targets. A real FD can help create revenue by enabling the customer, but that is different from carrying a sales number. The cleaner test is whether the role is evaluated like a seller or like a technical partner. The fastest check is to match the metric to the role. Quota points toward sales-adjacent work, while production adoption points toward field engineering, and when the title conflicts with the metric should win. The overlap makes sense once you see what both roles share and where they diverge. The real confusion comes from the fact that both people talk to customers and both need enough technical depth to be credible. A sales engineer has to understand the system well enough to uncover integration risk before a deal is signed. A forward-deployed engineer has to understand the product well enough to explain it clearly and support the customer in a live conversation. The overlap fades once you ask what each role is trying to accomplish. The same technical skill can serve different goals, and that goal is what separates the jobs. For a sales engineer, the outcome is tied to the deal. The work is succeeding when the customer agrees to move forward, the evaluation looks promising, or the sales process keeps advancing. For a forward-deployed engineer, the outcome is tied to adoption in the real system. The deployment has to hold up, the workflow has to get used, and the customer has to see measurable value once the product is running. That gives you two different clocks. One role is trying to shorten the path to signature. The other is trying to shorten the path to actual value after the product is live. AI systems often look polished in a demo, but break down under enterprise constraints like reliability, integration, and workflow fit. That is why the second problem usually takes more effort to solve. The hiring decision comes down to one practical question. Where is the biggest uncertainty right now? If the uncertainty is about closing deals, the first hire should reduce sales friction. If the uncertainty is about getting the product to work in real settings, the first hire should reduce delivery risk. A founder has to separate two very different problems. One is convincing people to buy. The other is making the system succeed after the contract is signed. When the main obstacle is buyer hesitation, you need someone who can translate the product into terms the customer trusts. That person helps answer objections, clarifies technical value, and keeps the sales process moving. When a sale is already won, but the implementation may fail, the need shifts. Now, the important work is fitting the product into a messy customer environment and preventing the first rollout from breaking. That split maps cleanly to the role family. Pre-sale uncertainty points toward sales, engineering, or solutions architecture. Post-sale uncertainty points toward forward deployment, where the job is to make the system work in practice. A simple rule helps when the choice feels vague. Identify whether the risk sits before the signature or after it, and hire for the stage where the biggest risk lives. Before the deal closes, the challenge is credibility. An SE-like function supports the conversation, proves fit, and helps the buyer feel confident enough to move forward. After the deal closes, the challenge is execution. An FD-like function works through integration, adapts to the customer's environment, and turns a promise into a live deployment. The best teams let both roles work together because sales promises and deployment reality affect each other. Even so, one role leans toward winning confidence before purchase, while the other leans toward making the product survive in production. Title labels are unreliable on their own, so the real skill is reading the wording around them and matching search terms to the actual work. That matters when you're trying to identify a role, compare postings, or screen for the right experience profile. Job titles are often noisy, especially in fast-moving companies. A better read comes from the body of the posting, where the responsibilities, tools, and customer context usually make the role much clearer. These examples make the naming problem concrete. The titles differ a little, but the surrounding language is what tells you what kind of work the role really involves. This title points to a deployment-oriented engineering role. The important signal is not just the label, but that it sits close to customer work and implementation rather than classic sales targets. Adding the word software makes the engineering side even more explicit, but the underlying function is still the same kind of customer-facing deployment work. The title variation tells you the wording can shift while the role remains close in meaning. That variation is the point. One company can use slightly different labels for very similar jobs. The stronger clues are the words about software depth, customer interaction, and production adoption, because those tell you the role is about making systems work in the field, not chasing quota. When compensation is not visible, the honest approach is to rely on what the posting actually states. Experience level shows up through requirements like integration work, production debugging, and cross-functional execution, and those are much safer to read than guessing at pay. Sales engineering roles usually emphasize a different mix: presentations, discovery conversations, pre-sale validation, and support for the commercial motion. The pay may still be strong, but the day-to-day experience points toward technical selling rather than deployment after the sale. Role names can change a lot from one company to another, so it helps to collect the families of titles you may encounter. Once you know the variants, you can search more broadly and avoid missing a posting just because the label is slightly different. This is the shorter form of the deployment-focused engineering label. It usually signals a role that mixes technical implementation with direct customer work. This version makes the software engineering expectation explicit. The core idea stays the same: build, adapt, and support solutions close to the customer environment. Applied engineer often means an engineering role tied to real-world use rather than abstract product development. The word applied usually hints at implementation, problem solving, and fitting the product to a specific setting. Customer engineer generally points to someone who sits between the product and the client. The work often involves technical support, integration, and helping the customer get value from the system. Solutions engineer is another flexible title, but it usually centers on shaping a technical solution around a customer need. That can include demos, architecture conversations, and hands-on validation. Sales engineer leans toward the pre-sale side of the process. The role often supports evaluation, explains technical fit, and helps move a deal forward with evidence and clarity. A technical account manager usually works after the sale, keeping the customer relationship healthy while solving technical issues. The focus is retention, adoption, and steady support rather than initial closing. Implementation engineer is strongly tied to rollout work. That usually means setting up systems, connecting tools, and making sure the customer can actually use the product in practice. Customer success engineer combines technical help with adoption goals. The role often lives in the handoff period, where the product is already sold and the job is to make sure it sticks. Field engineer usually means hands-on work outside a central product team, often close to deployment or on-site support. The title suggests practical problem solving in the environment where the system is being used. The title matters, but the surrounding words are even more diagnostic. If you want to classify the role correctly, scan for terms that reveal whether the job is about selling, deploying, or supporting a live customer system. These words usually belong to commercial motion. When a posting talks about quota, pipeline, or bookings, it is telling you that revenue generation and deal progression are part of the job. These terms point in a different direction. They usually describe getting software into use, making it fit the customer environment, and helping the system produce value quickly. These phrases mark the transition after the sale has closed. They show that the job is about guiding a customer through adoption, responding to issues, and feeding real-world experience back into the product. That language usually separates two kinds of experience. SE roles tend to highlight presentation, discovery, and commercial support, while FD roles highlight engineering depth, production debugging, and cross-functional execution. Either one can be strong, but they prepare you for different paths. The practical rule is to ignore job titles for a moment and read the work the role is actually built to do. That makes it easier to tell whether a position is about selling a solution, deploying it, or supporting it after launch. A useful habit is to slow down and inspect the role in a fixed order. That keeps you from reacting to branding and pushes you toward the signals that describe the real job. Start with the outcome the role is optimized to produce, because that usually reveals the employer's intent. Quota language points toward revenue pressure and selling, while deployment language points toward implementation, delivery, and getting the product working in practice. That check protects you from titles that have been repackaged for convenience. An SE and an FD can sound similar on paper, but the actual balance between pitching value and operationalizing it can be very different. The next boundary is harder because post-launch work often overlaps at exactly the moment ownership shifts. The real question is who takes over customer responsibility, and when the FD stays close enough to keep the implementation on track. FD work is about getting a deployment across the finish line, while CE and TAM work is about keeping the account healthy after launch. The difference matters because both roles can sound customer-facing, but they solve very different problems. In enterprise AI, the difficult part is often the early, messy phase. Once the system is stable and the customer starts using it in a repeatable way, the job changes from building something new to supporting something established. That confusion shows up a lot in hiring. A company can describe the work in broad terms, but the real question is whether the person is expected to finish the implementation or operate the relationship around an already working system. That question cuts through the title. If the main job is delivery and integration, the role leans FD. If the main job is account health, support, and coordination after go live, the role leans CE or TAM. An FD stays close to the implementation itself. They connect systems, debug edge cases, adapt workflows, and remove friction until the product works in the customer's real environment. A customer engineer or technical account manager shifts attention to the account over time. That means monitoring adoption, handling escalations, supporting renewals or expansion, and preserving the technical relationship so the customer keeps getting value. That line marks the handoff. One role creates the working path, and the other makes sure the path stays useful, supported, and busy once customers are relying on it. Before the handoff, the work is about getting a difficult customer problem into a working state. After the handoff, the work shifts to keeping that system healthy, adopted, and useful over time. The starting point is usually some form of technical friction. The customer has a promising AI idea, but the path from prototype to production is still broken in a few important places. The workflow may work in isolation, but it cannot yet talk to the systems the business already relies on. That means the value stays trapped inside a demo instead of reaching real operations. A brittle prompt or retrieval layer means small changes can break the behavior. In practice, that makes the experience hard to trust because the system is too sensitive to noise or edge cases. Production use needs consistency. If the output varies too much or fails in important cases, the customer cannot put it in front of real users or real work. A pilot can prove interest, but adoption means the team actually changes how it works. If that jump fails, the project stays experimental instead of becoming part of the business. At that stage, the FD is working inside the messy part of the problem. They write glue code, test failure cases, coordinate with product and infrastructure teams, and translate between business goals and system design. Success is not theoretical. It shows up when the workflow runs, people use it, incidents fall, and the customer can point to a real operational result. Once the deployment is live, the central question changes. The challenge is no longer whether the solution can be built, but whether it can stay dependable as real usage begins to shape it. That is where CE and TAM work takes over. Their job is to keep the account healthy, handle support, route escalations, watch usage patterns, spot adoption gaps, and look for signs that the customer is ready for more. A simple rule helps separate the two roles cleanly. It turns the handoff into a decision you can make from the state of the account, not from job titles alone. The transition makes sense when the core system is steady and the customer is starting to grow into it. At that point, the hard technical build work is mostly done, and the relationship needs steadier operational ownership. That sentence captures the rule directly. Stability tells you the solution no longer needs constant rescue. An expansion tells you the customer is moving beyond the original narrow use case. Stable means the deployment can keep functioning without repeated engineering intervention. Expanding means the customer is starting to spread the system across more users, more teams, or deeper parts of the workflow. That is the moment when the work shifts from building a path to extending the value of the path already built. The FD does not vanish. They may still help with new features, deeper integrations, or the next rollout. But the center of ownership moves to the TAM, who carries the day-to-day relationship while the FD acts more like a specialist resource. Role titles get confusing fast, so the real job is to compare what each role is accountable for. The useful question is not the name on the badge, but what success looks like in practice. That framing cuts through a lot of title noise. When two jobs sound similar, the easiest way to separate them is to ask what outcome the company measures for each one. Each role points at a different outcome. An FD is judged by whether the product actually works for the customer in production, while a customer engineer is judged by responsiveness and technical trust after launch. A TAM sits closer to account health and coordination, and a sales engineer supports the deal itself by proving value and helping the sale move forward. Company labels are inconsistent on purpose or by habit, so the title alone can mislead you. A customer engineer at one company may look like a solutions engineer at another, and a TAM may overlap with a customer success manager. So the incentive behind the role tells you far more than the name. The incentive gives away the behavior. If the role is paid to close the gap between product and production, it behaves like an FD. If it is paid to keep a live account technically healthy, it behaves like a CE or TAM. That lens makes unfamiliar titles much easier to decode. The home building metaphor makes the role split easier to hold in your head because it separates building a house from maintaining one. That distinction matters when someone has to decide which team should own a customer problem. A house gives a concrete way to compare two kinds of work that can look similar from the outside. Both involve the customer, but the kind of problem being solved is very different. Start with the construction phase in your mind. Raw land, design plans, crews, inspections, and all the surprises that show up when theory meets reality. That setting makes the first role easy to place. The FD belongs in the messy build phase, where the hard part is making the system fit the actual environment. Foundation issues, plumbing reroutes, and blueprint versus lot conflicts are all examples of work that needs a builder's mindset. The customer engineer, or TAM, is closer to ongoing property care after people are already living there. The job is to keep things stable, track changing needs, and handle the kinds of issues that come up during normal use. That's why the handoff gets tricky. Both roles face customer-facing issues, but one solves build time problems and the other solves day-to-day operation problems. If the customer still needs construction help, handing off too early leaves unfinished work behind. If the house is already settled, keeping the builder around wastes specialist time. Once that difference is clear, staffing and escalation decisions get much easier to defend. The real question becomes whether the customer needs a builder right now or someone who can keep the place running. The incentive boundary is what separates one role from another in practice. When that boundary is blurry, people end up doing work that their title does not really support, and the team starts drifting into confusion. A title may sound clear, but the incentives underneath it can point in different directions. Once compensation, goals, and expectations are mixed together, the role stops behaving like a clean job definition and starts behaving like a compromise. The label on the org chart is not enough. An FD can be treated like support, a TAM can be asked to build code, and neither title by itself tells you whether the person is really selling, building, supporting, or renewing accounts. The fastest diagnosis comes from separating ownership, measurement, and handoff. Those three questions make the hidden incentives visible. The first question tells you whether the person still owns technical implementation. The second shows whether the job is being judged by support quality, adoption health, and expansion readiness. The third reveals whether there is a real handoff once the system becomes stable. If implementation is still the main ownership, the role belongs on the FD side. If the metrics are centered on customer health and future growth, that is CE or TAM territory. When the system settles down and the account moves over, the boundary between those roles becomes real instead of merely nominal. A handoff usually happens when the problems shift from getting the system working to keeping it working at scale. The important part is the change in ownership. One role builds and stabilizes the first version, and another role takes over long-term customer care. The pattern becomes easier to see in a concrete example. A short story like this shows how the work changes once the product leaves the first deployment phase and starts living inside a real customer environment. At the start, the focus is technical survival, connecting systems, reducing bad answers, and making the model fit the workflow. That early work is hands-on and often messy because the assistant has to become reliable enough for people to trust it at all. Once daily usage starts, the problem stops being pure implementation and becomes operational trust. Growth brings new teams, new expectations, and more pressure on stability. So the customer starts caring less about weekly fixes and more about durability. At that stage, the account function takes over the steady relationship work. They track health, coordinate issues, and keep stakeholders aligned, while the FD only comes back when the account needs deeper technical help or a new integration. The feedback loop matures along with the account. Early signals are about what prevents adoption. Later signals are about what threatens retention, like training gaps or governance friction, and that is why the technical feedback now sits inside a broader customer structure. Role names shift from company to company, so the search strategy has to focus on function as much as title. The goal here is to spot the same job, even when the label changes, and to read the posting for what the company really needs. A posting may hide in plain sight under a different name, but the work it asks for is usually recognizable. Searching by the underlying function gives you a better chance of finding the roles that actually match this career path. Forward deployed engineer usually points to someone who works close to the customer and helps get the product working in a real environment. The important clue is the blend of engineering and deployment, not just the title itself. Forward deployed software engineer is a very close cousin of the FDE role, but the wording often leans even more clearly toward coding and integration. That tells you to expect hands-on technical work, not a purely account-facing job. Customer engineer often signals a role that sits between technical work and customer support. The job usually involves helping the customer adopt the product and solving technical issues along the way. Technical account manager usually means long-term ownership of the account after launch. The technical side matters, but the center of gravity is health, coordination, and keeping the relationship moving smoothly. Solutions engineer often shows up in roles that support sales or implementation with technical depth. The work can involve demos, integrations, and problem solving around a customer's use case. Customer success engineer usually combines technical support with adoption work. The key question is whether the posting wants someone to build, fix, and guide, or mainly to manage the customer relationship. Field engineer can be a broad label, but often means working close to the customer site or deployment environment. That makes the setting and the delivery problems just as important as the engineering itself. The title gives a first clue, but the real evidence lives in the job description. The verbs, responsibilities, and required experience tell you whether the role leans toward building, supporting, or owning accounts. FDE postings usually keep pulling you back toward hands-on software work. When a language mentions debugging, integration, production issues, and collaboration with product or infrastructure teams, the role is leaning hard toward engineering delivery. CE and TAM postings usually point to the life of the account after launch. The recurring signals are support, adoption, escalation handling, and responsibility for keeping the customer relationship healthy over time. When both sets of signals appear together, the company is often mixing two different job families. That usually means the boundary between engineering delivery and account ownership is not very clean inside the organization. Pay and experience expectations vary a lot by location and company, so one posting should never be treated as the whole market. Even so, the pattern is useful. Deep engineering plus repeated post-launch ownership usually means the role sits somewhere between FD, CE, and TAM. A couple of current postings make the pattern concrete. The point is to compare title, location, and job description language so you can read the role the way a recruiter or hiring manager would. These examples come from company-written job descriptions, so they're the company's own framing of the role. They still need to be checked right before publication, because postings can change quickly. That title already signals the role family, and the New York City location gives you another concrete filter. The wording suggests customer-facing deployment work with strong software engineering, production debugging, and close coordination with internal teams. This title sits very close to the FD role, but the software engineer wording pushes the emphasis toward coding, integration, and implementation. The real signal is the qualification section. Look for production debugging, systems thinking, and direct customer deployment work, and do not guess a pay if it's not listed. The same method works across companies. Record the exact title, the employer, the location, and the verbs in the description. If the posting stresses post-launch support and account health, it looks like CE or TAM. If it stresses coding, debugging, and systems integration, it looks more like FD or forward-deployed software engineer. The interview question is whether success depends mainly on making the system work in production or on keeping the live account healthy after it works. That answer tells you which seat you are really looking at, even when the title is vague. The useful question here is who owns the customer once the work stops being experimental and starts becoming routine. That boundary decides whether the role is mainly about getting a deployment working or about keeping the relationship and the product value healthy over time. For a founder, that means looking past the job title and deciding where customer ownership actually sits. For a recruiter, the incentive structure matters more than the label because titles can hide very different responsibilities. For a candidate, the real clue is in the post-launch work, support, adoption, expansion, and long-term account health. That boundary becomes much clearer when you separate the first stable result from the ongoing relationship. An FD is judged on getting the deployment to a reliable point. A CE or TAM is judged on making sure that value persists, deepens, and expands after the launch phase. Once that split is clear, the comparison with a consultant gets easier. Both roles may face the customer directly, but one is usually accountable for building and stabilizing a real system, while the other is more often brought in to advise, analyze, or guide without owning the long-term operating outcome. The contrast here is about deliverables and accountability. A consultant is hired for advice, while an FD is hired for a system that has to work in the real world. That difference changes how both roles are measured and why the job feels so different from the outside. That confusion is common because the same job title can hide very different expectations. One side is trying to buy traction fast, while the other side is trying to figure out whether the work is strategy, delivery, or hands-on build work. The important distinction is ownership of the artifact at the end. If the output is only a recommendation, that is a consulting model. If the output must function in production, the role is much closer to an embedded builder. Presentation skill can hide a lot, but it does not tell you whether the work will survive after the meeting ends. In practice, accountability for the result is what separates someone who advises from someone who owns delivery. A traditional consultant is usually paid for a deck, roadmap, or transformation plan. An FD is paid for a live system that keeps working after handoff, so the incentives, timelines, and success metrics all shift toward reliability and real operational impact. The deliverable is the thing the client can actually use or reject, and that changes what the work really is. In some settings, it is a report or recommendation. In FD work, it is software that runs in the customer's environment and keeps working there. A deliverable is not just effort or expertise. It is a concrete outcome that can be judged. Consulting often ends with information, while enterprise software work often ends with something operational that changes how the customer works. AI makes that distinction sharper because the prototype is usually the easy part. The real problem starts after the demo, when the system has to survive access rules, messy data, latency limits, monitoring, training, rollback, and governance before it becomes normal production behavior. FD work sits exactly in that gap between a promising prototype and a system that keeps running in production. The role is defined by making the thing work where the customer actually lives, not by handing over advice alone. Consultant work and FD work can both be valuable, but they point toward different kinds of results. The difference shows up in what gets produced every day and what the organization can actually use afterward. A consultant often brings structure to a messy situation. That work can sharpen the problem, get people aligned, and help leaders make a decision, but the main thing being produced is still usually an artifact that supports the decision. An FD is measured more by what changes inside the system itself. The focus shifts from presenting an answer to building, connecting, and improving the thing that people actually use. A simple comparison makes the contrast easier to see. One side is centered on documents and decisions. The other is centered on working software and operational change. The contrast becomes very concrete in the deliverables. Consulting tends to produce materials that help the business decide, while FD work produces systems that the business can run on. Success is not just approval, but steady adoption and fewer manual fixes. A useful way to judge the role is to look at the daily output. If the work is mostly slides, memos, and operating model documents, it sits closer to consulting. If the work is code, integration, user feedback, and production fixes, it sits much closer to FD work. Consulting breaks down when the work stops at the plan and starts with the real system. The gap between a clean proposal and a working AI deployment is where most of the trouble appears. A consulting model often assumes the client team can carry out the design after approval. AI projects expose that assumption quickly because approval does not solve integration, change management, or operational detail. An AI system is not a single deliverable. It is a chain of components that have to work together. Prompts, data access, permissions, user habits, and evaluation all affect whether the system is actually usable in the organization. That is the core reason the old consulting model breaks down here. The problem is not just producing a recommendation. The problem is making the recommendation survive contact with the real workflow. A prototype often works in a controlled setting, but production adds reliability, security, scale, and maintenance. Those demands change the shape of the solution, so the team has to redesign parts of it rather than simply pass it along. Many AI failures come from the surrounding process. Who approves the response, where the data comes from, and how the result enters the existing system. Even a strong model fails if the workflow around it is awkward or slow. Adoption depends on how people and the model share the task. If the human steps are unclear, The AI feels like extra work instead of a useful tool. Evaluation cannot end at deployment because model behavior and user behavior both change over time. The system has to be measured in use so drift, failures, and new edge cases are caught early. An FD is built for that kind of work because the job continues after the slide deck is finished. The focus shifts from presenting an idea to making the system operate, adapt, and hold up inside the client environment. This part separates polished advice from working delivery. A good deck can identify the right problems, but ship value depends on whether the system can actually connect to real workflows, real permissions, and real users. A consultant can do the interviews, frame the use cases well, and present a clean rollout plan, and that often earns immediate support. The problem is that approval is not the same thing as a working system, so the hard part may still be untouched. That stall usually means the idea was right, but the path to production was incomplete. Something in the operating environment is blocking progress, and that is where many well-received plans start to fail. Once the assistant meets the real organization, every hidden dependency shows up. Access rules, trust, error handling, and measurement matter because daily use depends on them, not on the elegance of the proposal. A field engineer approaches the problem from the other direction. Instead of beginning with a broad recommendation, the focus shifts to the smallest workflow that can actually reach users and prove value. That means wiring the integration early, defining success before launch, and making adoption visible from day one. The system is then adjusted with real user behavior in mind, so it can survive contact with the deployment lifecycle rather than collapse after the demo. One points toward change on paper, and the other produces something people can actually use. The difference is not the ambition of the idea. It is whether the work reaches the point where the system holds up in production. The useful comparison is not whether a demo worked, but what changed once an FD touched the project. That shift from prototype to production tells you what the role really adds. These four questions force a practical distinction. What was broken, what changed, how adoption was measured, and what the team learned from real use. They move the discussion away from impressions and toward evidence. Each question probes a different part of the transition. The first identifies the gap. The second identifies the engineering response. The third checks whether people actually used it. And the fourth shows whether the product improved because of production feedback. A side-by-side view makes the shift easier to see. The table separates the early proof-of-concept mindset from the discipline required once the system has to work for real users. The pattern is consistent across every row. Before FD involvement, the work can look impressive but stay fragile. After involvement, the system is shaped for reliability, measurement, and adoption, with concrete feedback flowing back into the product. Two ideas explain why this distinction matters in practice. They connect the technical work to whether the customer actually gets value from it. Time to first value is about the first outcome that matters in a live environment. A polished demo does not count if the system still sits unused when real work starts. Handoff discipline means ownership is clear when the project shifts from building to running. In FD work, that matters because the same team often has to keep the system healthy after launch, not just deliver a finished presentation. That is why agent reliability and governance sit so close to the FD role. Wrong permissions, brittle actions, weak escalation paths, and poor audit trails can all break a system that looks good on the surface. So governance has to live inside the product and the operating process. Consulting and FD work differ most clearly when you compare the kind of outcome each role owns. One role shapes the plan, and the other makes sure the system actually works in practice. A consultant usually helps define the structure of the problem, set direction, and spot risks before anything is built. An FD goes further into execution, where the details have to survive contact with reality. Integrations, reliability, and whether the system can be used every day. That difference is not about importance, it is about deliverables. A strong consultant can improve the way a company thinks, while an FD is responsible for turning the AI system into something that runs, connects, and keeps working. Job titles and posting language often reveal whether a role is centered on deployment, customer work, or pure product engineering. The goal here is to read past the label and spot the signals that matter before applying. A title can be vague or even misleading, but the requirements and responsibilities usually expose the real shape of the job. That wording tells you whether the role is closer to consulting, implementation, or hands-on engineering. Titles in this space move around quickly, so a search term that worked last month may not match the current careers page. The safe habit is to verify the live posting and use several search phrases, not just one label. That phrase usually points to engineering work that is embedded with a customer or deployment setting. It suggests proximity to real systems and real users, not a detached, office-only role. Adding software engineer usually raises the signal toward deeper build responsibility. The role still sits close to deployment, but it often expects stronger hands-on coding and system ownership. Customer engineering often means solving technical problems directly for a client-facing use case. The work can include setup, integration, and troubleshooting, all with the customer's workflow in view. Solutions engineer roles usually sit near pre-sales or implementation, where the job is to adapt a product to a specific environment. The strongest clue is whether the posting asks for technical depth along with client communication. Implementation engineer points toward getting software working in a real setting after the sale. That can mean migrations, configuration, onboarding, and making sure the system actually functions in production. Applied AI engineer usually signals someone who turns models into practical systems. Look for evaluation, deployment, and product constraints, because the role is about making AI useful rather than just researching it. Embedded engineer can mean two different things depending on context: hardware-level software or a person embedded with a customer team. The posting details have to tell you which version is meant. A pair of concrete examples makes the pattern easier to read. The title, the scope, and the compensation language all point toward the kind of ownership the role expects. One title leans toward deployment-heavy, customer-facing engineering, while the software engineer version hints at deeper coding responsibility inside that same environment. The important part is not the exact label alone, but the mix of ownership, integration, and customer contact that the posting describes. When salary is listed, The useful question is what kind of responsibility the pay band is attached to. A role that owns production outcomes and field deployment should be read very differently from a role that mainly advises or supports. The experience section often gives away the real job, even when the title stays vague. That is where you look for evidence of product ownership, technical depth, and direct work with customers or systems. Production ownership means the team depends on you after the demo is over. If the posting stresses that kind of accountability, the role is much closer to engineering responsibility than to a pure sales support function. Shipping matters, but maintenance matters too. A role that includes both is asking for someone who can build, stabilize, and keep systems running in the real world. That combination means the role is part problem framing and part technical execution. You are expected to understand the customer's need and then turn it into a working system, not just repeat requirements back to a team. Those integrations are a strong signal that the job lives inside messy real-world infrastructure. Roles like that often need someone who can connect to existing systems and make the product fit the customer's environment. These terms point to maturity in the role. A posting that asks for measurement, evaluation, monitoring, and rollback planning is telling you that reliability and iteration are part of the day-to-day work. The simplest way to separate these roles is to ask what each person is accountable for. One role helps the organization choose the right thing. The other helps it build, ship, and keep using that thing successfully. A single sentence can anchor the distinction when the details start to blur. Keep the rule compact enough to remember, because this comparison only works if you can apply it quickly. Consultants are judged by whether they improve decision-making, so their work ends when the organization has better understanding and a direction to choose. FDs are judged by whether the chosen thing actually reaches users, works in production, and keeps getting adopted. That difference in accountability changes what gets handed over. A consultant can finish with clarity and recommendations, while an FD has to leave behind software that runs, adoption that sticks, and feedback loops that improve both the product and the deployment. Once that boundary is clear, the contrast with a machine learning engineer becomes easier to see. Excellent model work may live in a different part of the system, with ownership centered on training, evaluation, or infrastructure rather than the full path from decision to durable use. The contrast here is about where each role sits in the product lifecycle. One role concentrates on making the model strong and measurable. The other concentrates on making that model useful in a real customer setting. That question usually appears right after a team has something impressive on the screen, but still fragile in practice. The demo works. The harder problem is turning it into something customers can actually depend on. That line points to deployment and integration. The concern is not whether the model exists, but whether it fits the customer's workflow, systems, and constraints. That line points to model quality. The focus is on data, training, evaluation, and the changes that make predictions more accurate or more reliable. They overlap, but they are not the same job. A good deployment can still fail if the model is weak, and a strong model can still fail if it never fits the real environment. That distinction matters because teams often blur technical success with product success. A system can look excellent in a lab and still miss the mark once real users, real processes, and real constraints enter the picture. The simplest split is that the ML engineer owns the model itself and the machinery that measures it, while the FD owns what happens when that model meets a customer workflow. That includes adapting the system, shipping it safely, and making sure success is defined by the business outcome, not just a metric on a chart. Thinking in layers helps. The model sits at the center, then come the tools and controls around it, and outside that lies the messy world of permissions, legacy systems, approvals, and compliance. The ML engineer usually works closer to the center, while the FD works at the boundary, where the system has to survive contact with the customer's environment. The ownership split matters because good model work and good customer deployment solve different problems. One side improves the model itself. The other side turns that model into something a customer can actually run, trust, and adopt. That's the cleanest way to frame it. Model work asks whether the system is accurate and robust, while deployment work asks whether it fits the customer's process and keeps working in practice. The table draws the boundary pretty well. The ML engineer stays closest to training, evaluation, and reliability of the model itself, while the FD stays closer to the customer and measures success by whether the system is actually useful in production. That's the important limit to keep in mind. Improving a classifier or hardening a serving stack is upstream work, but does not solve the day-to-day integration problems that appear when a real customer tries to use the model inside their own process. The FD takes the model as a starting point and builds the rest of the system around it. That means wiring into customer tools, shaping handoffs between people and automation, and adjusting the deployment once real usage exposes what is missing. A concrete example makes the boundary easier to see. The same model API can look complete from the model team side and still be far from ready for a real customer workflow. Assume the core model team has already built the service behind the API. At that point, the model exists, the endpoint exists, and the remaining question is how a customer can use it safely and productively. That endpoint is the core interface from the model side. It gives access to the model, but does not by itself solve business logic, permissions, or workflow design. Those evaluations tell the team how the model behaves before it reaches a customer. They are essential, but they are still controlled tests, not the Messier conditions of a live support process. The serving layer makes the model available reliably. Even so, availability alone does not mean the customer has a usable product, because the workflow still has to be designed around how people work. Monitoring and safety tools give the team visibility into failures and misuse. They are necessary foundations, but they do not decide how the model fits into a real business process. Now the problem changes. The customer is not evaluating a benchmark. They're trying to help support agents respond faster without breaking policy, tone, or escalation rules. From the ML engineer's side, the job is to make the model stronger and more reliable. Better benchmarks, fewer failures, and higher throughput all help, but they still leave the customer's operational questions unresolved. That is where the FD starts doing the real integration work. The customer wants a working process, not a raw model, so the deployment has to match their queue structure, access rules, review steps, and business constraints. First comes understanding the path a ticket takes through the organization. Without that map, it is hard to know where automation helps and where a human has to stay in the loop. Then the FD decides which tasks the model should actually do. Some steps are good for generation, some for classification, and some should be handed off instead of forced through the model. Retrieval keeps the model grounded in the customer's own information. That matters because support replies are only useful when they cite the right policies, articles, and product details. Some categories need review before anything goes out to the customer. The FD has to decide where that guardrail belongs so the team can keep speed without losing control. Logging makes the system auditable. If something goes wrong, the customer needs to know what the model saw, what it produced, and where the decision path broke down. A deployment also needs an escape hatch. If quality slips, the customer should be able to disable the model quickly and return to a safe fallback without stopping the business. The final piece is choosing the right success measure. For the customer, value shows up in workflow speed, coverage, and actual use, not just in model scores. That comparison shows the shift in ownership. Before FD involvement, the model may be impressive but not operational. After FD work, the system starts behaving like a product the customer can rely on. Before the deployment work, the model exists in theory but not in practice. It might look good in testing and still fail to fit the customer's constraints or operating rhythm. After the deployment is shaped properly, the customer has something they can actually ship. Instrumentation then tells the team whether people use it, where it helps, and where it still needs adjustment. That feedback loop matters because the field teaches the team what the lab could not. Real usage reveals which prompts hold up, which guardrails are necessary, and which workflow choices make the system usable. The essence of the role is that loop between customer reality and system design. The FD makes the deployment work, learns from what happens in production, and feeds those lessons back into the product and model team. LLM application architecture is the set of choices that turns a model into a working product. The important part is not just the model itself, but how it gets context, how it acts, and how the system handles risk and quality. When people hear the phrase, it can sound technical, but the idea is simple. An application needs rules for what the model sees, what it is expected to do, and what happens after it responds. Those 5 questions cover most of the architecture. You decide where context comes from, what task the model performs, who checks the result, how uncertainty is handled, and how performance is measured with logs, evals, and feedback. The ML engineer focuses on the technical core, the model behavior, the data, and the validation. The FD often shapes the surrounding workflow so the system fits a specific customer, even when the model itself stays the same. That is why many enterprise problems are solved by the surrounding system rather than by a bigger model. Better prompts, better data access, stronger review steps, clear fallback behavior, and good instrumentation often matter more than raw model size. The hard part is not only making the model smarter. The harder part is fitting it into a workflow people can actually use, trust, and keep using. A model can answer well and still fail in production if the surrounding process slows people down or creates extra friction. Adoption depends on the whole system around the model, not just its output quality. In a claims team, a solid summary still fails if someone has to copy the same data into several systems by hand. And even a strong draft will be ignored if reviewers cannot tell where it came from or whether it is reliable. Put the AI at the wrong point, and it becomes extra work instead of real help. That changes the metric of success. Model builders care about the model itself, while deployment-focused engineers care about whether the customer actually accepts the system and relies on it. That is the model-centered question. Did performance improve? Did accuracy rise? Did the system produce better predictions? It stays focused on the quality of the model artifact. That question is about real adoption. The system only matters if people rely on it in their daily work, believe the output is safe enough, and come back to it instead of abandoning it after the pilot. Once agents and LLM workflows touch real work, reliability and governance become central. The deployment needs permission boundaries, audit logs, approval steps, and rollback paths, and the engineer has to balance autonomy against control so the system is useful without becoming risky. The cleanest way to tell these roles apart is to look at what the job rewards. Pay attention to the outcome a person is judged on, because that usually reveals whether the work is centered on models or on customers and production use. That question cuts through job titles very quickly. When the incentives are different, the day-to-day work usually follows those incentives. When success is measured by model quality, evaluation results, or infrastructure reliability, the work stays close to the technical core of the system. Those are the kinds of metrics that usually point to ML engineering. When the scorecard is adoption, customer happiness, workflow fit, or revenue retention, the role is oriented around making the system work in a real setting. That pulls the job toward field-facing implementation and customer success, which is where FDE work lives. A useful shortcut is to combine three signals and judge how strongly they show up in the role. Customer-specific adaptation means the work changes for a particular client. Production ownership means the role does not stop at a prototype. And closed-loop learning means lessons from deployment feedback into the product. The more all three are present, the more the role behaves like an FD role. That expression is a guide, not a rule written in stone. It helps you compare roles that sit somewhere between pure model work and customer-facing delivery. A good comparison is two openings built around the same API. The technical base can be identical, but the job can still point in very different directions depending on what the person owns. That kind of posting centers on measurement, experimentation, and model tuning across datasets. The responsibility stays inside model development and evaluation, which is why it reads as ML engineering. This version is built around one customer and the realities of deployment. It asks for integration, adoption tracking, debugging in the field, and communication back to product, so the ownership is much closer to FDE work. Both roles can use the same model API, but they sit on different sides of the responsibility line. Once you identify who owns the customer outcome versus the model system itself, the role becomes much easier to place. The useful distinction here is not the API itself, but the job each person is doing around it. One role improves the model, and the other role makes that model work inside a real customer environment. A single interface can hide very different responsibilities underneath. That is why two people can touch the same system and still focus on completely different problems. Start with a shared starting point, one language model endpoint. From there, the difference comes from whether you're optimizing the model itself or shaping how customer uses it. The ML engineer works closer to the model layer. Latency, evaluation quality, safety behavior, and serving reliability are the main concerns, and the work may stay entirely on the engineering side without direct customer contact. The FD takes that same model and connects it to the customer's actual process. That can mean prompt chains, retrieval over company documents, routing results into CRM or ticketing tools, and adding a human review step where it matters. When someone asks why a response appeared, the explanation depends on which layer you control. Model behavior and evals point to the ML side. Workflow design, prompts, retrieval, logs, and approvals point to the FD side. That difference is about where the technical weight sits, not about who is more customer-focused or more technical. Both roles need depth. They just apply it in different places. Success metrics often separate roles that sound similar on paper. The job title matters less than the outcome the team is actually measured on. A role can look like one thing from the outside, but the metric tells you what work truly counts. If the team is rewarded for model quality, system performance, or customer adoption, that usually exposes the real shape of the job. The pattern is pretty clear. Model-centric outcomes point toward ML engineering, while customer-specific delivery and adoption point toward FD work. The strongest clue is where the value shows up, inside the model and serving stack, or in a deployed workflow that a customer actually uses. Enterprise AI usually needs both kinds of work at the same time. One person is not usually expected to own deep model metrics and customer-facing delivery equally well, so the team shape has to match the metric shape. Job titles in this area are often inconsistent, so the description matters as much as the label. The goal here is to learn the names and keywords that usually point to this kind of work. A role can be labeled in several different ways, but the underlying work is easier to identify if you read the responsibilities closely. That gives you a better filter than trusting the title alone. This title usually points to engineering work that happens close to the customer, often in messy real-world settings where the code has to work in production, not just in a lab. This version keeps the same customer-facing idea, but it often sounds a little more explicitly software-focused. The day-to-day work still tends to center on deployment, integration, and ownership after launch. This title often appears when the company wants someone to apply AI in a product setting rather than train models from scratch. The word applied is a clue that implementation and delivery matter. Embedded work can mean being placed directly into a team or customer environment, where the engineer has to understand the system deeply and adapt quickly to constraints on the ground. This title often appears in roles that blend engineering with customer interaction. The emphasis is usually on making a product work for a specific customer, not just building generic features. That title usually suggests system design, customer alignment, and implementation planning. It often sits closer to pre-sales or architecture work than hands-on product engineering. That wording is a strong sign that the job is about getting models into real environments and keeping them working there. Deployment, monitoring, and integration usually matter more than model research. This can be a broad label, but it often means the person is expected to translate technical systems into customer outcomes. The real question is how much ongoing ownership the role carries. Specific postings like these are useful because they show how similar work gets split across slightly different labels. The market changes quickly, so live pages are the only reliable source when you need current wording. Job pages change, so the list should be used as a pattern, not a fixed rule. What matters is whether the posting signals deployment, customer work, and accountability in production. A posting that asks for several years of experience is often looking for someone who can handle ambiguity and make decisions independently. That usually means more ownership than a narrow implementation role. When the role mentions direct contact with customers, the engineer is expected to communicate, adapt, and solve problems outside the codebase. That is a major sign of field-facing work. These keywords point to the infrastructure around the product, not just model training. They suggest the job involves making systems reliable, secure, and usable in real deployments. Delivery language shows whether the person is expected to carry the work all the way into production. If the posting talks about rollout and post-launch support, that is a very strong signal. Some jobs want more than generic coding skill. They want someone who understands the business domain well enough to work inside real constraints and specialized workflows. These are the terms that help you search for the right kind of role across different companies. They usually reveal whether the work is about getting a system adopted and keeping it healthy in production. A recruiter can rename the same job to make it feel more engineering-heavy, more customer-heavy, or simply more impressive. That is why the language inside the posting matters more than the label on top. The first cluster points toward deployment and customer integration, which is much closer to FDE work. The second cluster points more toward ML engineering, where the core problem is model performance and evaluation design. The search strategy is simple. Read for production and ownership language, not just for job titles. Those keywords tell you how the company actually expects the role to operate. This means the person is accountable for what happens in the real environment, not only for writing the initial code. It usually implies responsibility after launch as well. That phrase means the solution has to be adapted to a particular customer's environment. It is a strong sign that the role lives close to implementation work. These systems are the plumbing of a real deployment. When a posting mentions them, the job usually involves making the product fit into an existing enterprise stack. Those are signs of production discipline. The team is thinking about reliability, safety, and what happens when the system behaves badly. This suggests the system is meant to work alongside people, not replace them outright. That is common in deployment settings where judgment and review still matter. Enterprise implementation usually means long sales cycles, real constraints, and close coordination with the customer. That is far more operational than a purely internal engineering role. That phrase means the model is not finished at training time. The system keeps changing after deployment as it meets real usage patterns and real data. The pattern is straightforward once you compare the wording. Pre-sales emphasis usually means solutions. Heavy model building language points toward ML engineering, and direct ownership of a specific customer environment is the clearest sign of FDE work. Compensation can give a quick signal about the kind of role, but the number alone can mislead. The real question is what the job owns and why the company values that work. Two posted ranges can look similar and still refer to very different jobs. Source quality, seniority, location, and stock or bonus structure all shift the number, so a headline range never stands on its own. A rough range can still be useful if you treat it as a sketch rather than a rule. The point is to compare the scale of the roles, not to lock in an exact market price. Field deployment roles can reach very high pay when they sit close to revenue, customer delivery, or specialized implementation work. Even so, the spread is wide enough that level and company matter a lot. Machine learning engineering can command even higher compensation at the top end, especially when the role is tied to scarce technical skill and core product leverage. The plus sign matters because exceptional cases can sit well above the typical band. Those numbers are only a starting point. A single company, location, or level can push a role outside the range, so any real decision should use current postings and direct compensation evidence. Pay can suggest seniority or demand, but it does not tell you what problem the role is meant to solve. Compensation works best as a clue, not an identity label. Responsibilities and ownership scope reveal the actual job, and that tells you far more than the headline number ever can. The same home building analogy still fits, and it helps separate two roles that are easy to blur. The point here is to compare what each person owns, not to rank them. A building analogy makes the difference concrete. One role is focused on the internals of the system. The other is focused on getting that system to work in the real environment where people actually use it. An ML engineer sits closer to the core design work, the materials, the structure, and how well the system holds up under testing. An FD sits closer to delivery, fitting the solution to the site, the customer's workflow, the local constraints, and the final handoff into real use. Both jobs require technical skill, but the target is different. One is about making the underlying model better. The other is about making that model work reliably in a specific setting. That is why FD should not be treated as a smaller version of ML engineering. The responsibility changes shape. It is not just about model quality, but about owning the experience of using the model in practice. A useful test is to ask where the work is centered. If the main job is improving the model itself, that points to ML engineering. If the main job is deploying, adapting, and sustaining the model inside a customer workflow, that points to FD work. That distinction is enough to spot the roles in a real organization and to answer the harder hiring question that comes after it. Choosing the first technical hires is a judgment problem, and the right judgment comes from the bottleneck the company is facing. The point here is to match talent to the failure mode, not to the fanciest title. A title can look impressive and still miss the real constraint. If the company is stuck, the best hire is the one who removes that specific block. When several candidates all seem plausible, the useful question is not which resume sounds strongest. The useful question is whether the business needs help learning the product, selling it, or getting it into customers' hands. A quick rule helps turn a vague hiring discussion into a concrete one. Once you name the bottleneck, the role you need usually becomes much clearer. If the product is still being discovered inside the customer workflow, an FD can sit close to users and feed those lessons back into the team. If deals are stalling on technical proof or solution clarity, an SE helps remove doubt before signature. If customers already buy but cannot get live reliably, an SA focuses on deployment, integration, and handoff. The important habit is to treat this as a tool, not a law. A hiring decision gets better when it is tied to the specific breakdown the company needs to fix. The better hiring question is about the constraint in front of the business, because the right person depends on where the work is stuck. A resume can tell you what someone has done. The bottleneck tells you what the company needs fixed next. A role title sounds neat, but it hides the real problem. When you ask where the journey breaks, what capability is missing, and what would improve fastest, you start from the work itself instead of from a job label. That question points to friction in the path from interest to value. If customers stall before they see results, the hiring need is usually tied to learning, deployment, or support at that exact breakpoint. Each missing capability suggests a different kind of hire. Product learning means you need feedback from real use. Deal support means you need help closing uncertainty. And implementation capacity means you need someone to make delivery actually work. That question forces a practical forecast. The best next hire is often the one that removes the most obvious drag from the system, not the one that sounds most impressive on paper. Once the bottleneck is clear, the role often falls into one of three patterns. Each one owns a different part of the path from product idea to customer value. A forward-deployed engineer sits at the edge of the product and the real customer environment. That role is useful when the main job is learning from live use and shaping the deployment, so the team can see what the product still needs to become. A solutions engineer matters most when the sale is blocked by technical doubt. The work is to reduce uncertainty for the buyer, show that the product fits the problem, and help the deal move forward. A solutions architect becomes important after the decision when the customer needs the system designed and stabilized. If the deal closes but the handoff breaks down, this role often fills the gap between promise and delivery. Titles are overloaded, so the same name can mean very different work from one company to another. The safe move is to read the actual responsibilities and match the hire to the bottleneck, not to the label. This example shows how the right enterprise hire depends on the bottleneck. The same product can need different support depending on whether the problem is workflow discovery, deal confidence, or implementation follow-through. Picture a team selling software into a real operating process, not a toy demo. Insurance claims work has many steps, many stakeholders, and a lot of room for friction, so small mistakes show up quickly. That gap between a decent product and a working customer rollout is the whole problem. Early pilots expose different failure modes, and each one points to a different kind of support. When the assistant surfaces the wrong fields, the customer cannot settle into a reliable process. The issue is not just correctness in the abstract. It is whether the workflow becomes usable day after day. A strong demo can still fail if the buyer cannot picture how the tool fits the current claims process. That kind of hesitation is often about trust, architecture, and fit, not raw product capability. Here the deal is signed, but the work is stuck in handoff. If no one owns the integration plan and the data sources are messy, progress slows even when the customer already wants to move forward. The mistake is to assume one broad hire fixes every kind of friction. A good team looks at the exact bottleneck first, because that tells you which role will actually unblock the business. When a main question is which workflow really matters, the company needs someone close to the customer and the product. An FD helps discover the right path by working through real usage, not just opinions. When the product vision is attractive, but buyers want confidence, a sales engineer creates leverage. They answer technical objections, shape the story, and make the solution feel safe to adopt. When signed customers are waiting on setup work, the pressure shifts to implementation. An SA helps turn a closed deal into a running deployment by keeping the handoff and integration on track. The useful question is not just whether someone was hired, but what actually improves afterward. The best sign is a reduction in friction that also sharpens what the company learns about the product. Before that role is in place, the team is usually improvising. Problems pile up because the company has not yet turned customer friction into a repeatable function. Without the right person, the team is often inferring the workflow from partial signals. That leads to wasted effort because the product may be optimized around the wrong user path. Inconsistent deployment usually means each customer is being handled as a one-off. That prevents the company from seeing a pattern it can repeat and improve. When the same objections keep coming back, the sales motion is carrying too much of the technical load. A specialist can reduce that drag by answering the hard questions in a more systematic way. Vague feedback is hard to turn into product decisions. The team hears dissatisfaction, but not the specific information needed to change the system intelligently. After the right role arrives, the work becomes more legible. The company can see the actual customer path, repeat a successful pattern, and measure a clearer outcome. That visibility matters because it replaces guesses with observation. Once the path is clear, product and delivery decisions can line up with how customers actually work. Repeatability turns a one-off win into a process. At that point, the company is not just solving a customer problem once. It is learning how to solve it again. The important metric depends on the bottleneck, but the pattern is the same. The hire moves something measurable that matters to the business. That is how you know the role is aligned with the real problem. Durable learning is bigger than closing a single deal. It means the team understands the product, the customer, or the deployment well enough to make better decisions next time. That is the signature of an FD. The work helps land the customer, but it also feeds real evidence back into product development. The hire pays off twice, once in execution and once in learning. This metaphor makes role boundaries much easier to see. Each hiring profile maps to a different stage of the customer journey, and that prevents people from being placed in the wrong job. That matters because hiring gets messy when the same title is expected to cover sales, technical depth, and delivery all at once. A clear metaphor gives you a cleaner way to decide who owns what. When the product fit is still being shaped, the job is close to the customer and the real-world environment. Someone needs to learn from the field, adjust the deployment, and help define what the solution should become. Once the solution is mostly defined, the challenge shifts to confidence and technical clarity. The work is to remove doubts, explain the structure, and help the buyer feel ready to commit. After the deal is signed, the hard part becomes making the pieces fit together. That role keeps the implementation stable by coordinating design, build, and handoff across the teams involved. The incentive structure matches those stages. Each role is rewarded for the kind of progress it is supposed to create, not for doing all three jobs at once. An FD earns value by noticing what happens in the field and changing the setup to fit reality better. The learning loop is part of the job. An SE is focused on turning technical interest into a decision. The work is about clarity, trust, and removing the last objections before signature. An SA takes over where commitment starts and execution begins. The goal is a delivery that works in practice, not just a contract that looks good on paper. The clean boundary is the point of the whole comparison. FD's own learning from the field, SE's own technical support during the deal, and SA's own the design and stability of delivery once the work is underway. Use these questions when the team is trying to decide which role will relieve the biggest bottleneck first. The goal is to match the hire to the real problem, not to the title that sounds most impressive. The idea is to compare the current pain against the kind of help each role can actually provide. That keeps the hiring decision tied to the business problem instead of personal preference. If the team still does not know what the product should be, then the problem is discovery. That usually points toward a role that can work close to the product and help validate the direction. When deals slow down because technical buyers need more confidence, the bottleneck is often pre-sale credibility. That kind of friction favors someone who can explain the product well and reduce risk in the sales process. If the sale succeeds, but the rollout struggles, the real issue is delivery. In that case, the hiring choice should focus on helping customers get value after the contract is signed. Sometimes the field is telling you that the product itself needs to change. A hire is valuable there when they can translate customer feedback into product improvement, not just support the current version. If the constraint is turning interest into revenue faster, then the hire should shorten the path from evaluation to purchase. That kind of role matters when deals exist, but conversion is too slow. When customers need smoother onboarding, fewer implementation issues, and better long-term support, the priority is stability. The right hire helps the account succeed after the initial sale and keeps the experience from breaking down. A field-focused engineer fits best when the problem sits between product capability and customer reality. They can work through the technical details while staying close to the use case. A sales engineer is the better first move when the main gap is technical selling. They help prospects understand the product, trust it, and move forward with fewer objections. A solutions architect fits when implementation and post-sale delivery are the main risks. They shape the customer setup so the purchase actually turns into working value. That conclusion usually means the team needs stronger feedback from the field. The hire is not just supporting customers. They are helping the company learn what to build next. That conclusion means the sales motion needs more technical support. The hire helps remove uncertainty in the buying process and makes the pipeline easier to close. That conclusion means delivery is the pressure point. The hire helps configure, integrate, and stabilize the customer environment so adoption can hold. Once the checklist points in a direction, a quick scoring sketch can help compare options side by side. It is a way to keep the conversation grounded in impact rather than instinct. This formula rewards work that solves a painful problem, creates business value, and can actually be delivered. Dividing by time to first value keeps slow payoff options from looking better than they really are. The numbers are only there to structure judgment. A founder can use them to compare choices that all sound plausible, then see which one addresses the current bottleneck best. The FD path scores well because the pain is high and the business value is strong, but the slower time to first value pulls the total down. That suggests a promising option, even if the payoff is not the fastest. The SE path rises because it is quicker to produce value and is easier to execute. Even with slightly lower pain, the faster impact can make it the strongest near-term choice. The SA path lands lower because the value is smaller, execution is harder, and the payoff takes longer. That does not make it useless. It just means it may be less urgent than the other two options right now. The point is to force an explicit trade-off. If buyer hesitation is the main blocker, the sales-oriented option can win on speed and impact. If product discovery is the real problem, the field-focused option climbs because the company still needs to learn what to build. That kind of comparison keeps the hiring decision tied to the work that unlocks progress. Job titles in this area are often inconsistent, so the real skill is reading past the label and finding the role's actual function. The goal is to spot what kind of work the job really involves, how it is compensated, and whether it fits your background. A single title can miss a lot because the same work may appear under several names. Searching by both the title and the function gives you a better chance of finding the roles that actually match what you want. That title usually points to someone who works close to the customer and adapts technical work to a real deployment. It often sits at the boundary between engineering, implementation, and client problem solving. This version usually signals a more software-heavy role, but still with direct customer context. The wording suggests both building and adapting systems in the field, not just writing code in isolation. That title often means a pre-sales or customer-facing technical role. The work may include demos, technical scoping, and helping a customer understand how the product fits their needs. A solutions architect usually focuses on designing how a product or system should be put together for a customer. The role can be technical, but it often centers on architecture, integration, and guidance. That label often means the work is about taking AI methods and making them useful in a real product or customer environment. It suggests applied delivery rather than purely research-oriented work. This title usually leans toward getting a system deployed successfully. The job may involve setup, integration, troubleshooting, and making sure the product works in the customer's environment. That role usually combines technical depth with customer interaction. The important clue is that the engineering work is happening alongside support, adoption, or deployment conversations. A field engineer often works outside a purely internal product team, closer to where the system is actually used. The title can cover installation, support, deployment, or hands-on technical work on site. The label alone can hide important differences. In public job pages, even closely related titles may signal different scope, different location expectations, and different levels of customer responsibility. So the responsibilities section matters more than the headline. When a posting is live, the text should tell you something concrete about pay and seniority. That means looking for the salary range, the equity language, and the experience demands right in the listing instead of relying on old reposts. Compensation details can show how transparent the employer is and whether the pay is adjusted by location. If those details are missing, the recruiter usually needs to clarify before you compare the offer with others. Experience signals tell you what kind of environment the company expects you to handle. A role that asks for enterprise deployments and customer-facing technical work is usually very different from one that emphasizes startup ambiguity or deep domain knowledge. A posting can sound impressive and still be vague about the actual job. The useful reading habit is to extract the operational signals that tell you how the role functions day to day. That distinction changes the shape of the job. Customer-facing roles spend more time with clients and stakeholders, while product-facing roles stay closer to the internal roadmap and the product itself. Those words usually mean the job is about making technology fit into a real environment. They point to hands-on implementation work rather than only building new features. Pre-sale support means technical work that helps win and shape a deal. The role may involve demos, discovery calls, solution design, and helping the sales team answer hard customer questions. Post-sale work starts after the contract is signed, when the focus shifts to making the product succeed in practice. That usually means onboarding, configuration, troubleshooting, and customer adoption. Some postings want the discipline and scale of enterprise experience, while others value the speed and flexibility of startup work. When both appear together, the job may be asking you to bridge very different operating styles. The label can be broad, but the responsibilities tell you what the job actually demands. Reading for those signals helps you judge fit, scope, and seniority before you spend time applying or interviewing. This part gives a simple decision rule for staffing around uncertainty. The point is to match the role to the problem the company is actually facing, not to the title people wish they had. When the future is unclear, the fastest way to decide is to ask what is slowing progress right now. The role should remove that bottleneck, because the wrong hire can look busy and still leave the real problem untouched. An FD fits early discovery work when customers are still shaping the product with you. That person helps turn vague needs into something concrete, so the team learns what to build before it hardens into a fixed plan. An SE matters when the sales motion is getting stuck. The technical side of the sale needs more depth, more clarity, or more trust, and that role helps move a promising deal past the point where it keeps slipping. An SA fits when the sale itself is not the issue, but implementation is. The contract may be signed, yet the handoff, setup, or customer environment is creating friction, so the job is to make delivery actually work. That is what makes the rule practical. Each title corresponds to a different failure point in the business. Instead of asking which role sounds important, you ask which obstacle is blocking momentum. Once that distinction is clear, the labels matter much less than the work being absorbed. The harder test is whether a company has renamed a role for prestige while keeping the same underlying job. The issue is that job titles can change faster than the work itself. The goal here is to learn how to tell a real forward-deployed role from a renamed pre-sales role. A hiring rule helps you choose who to bring in first, but a detection rule helps you inspect the job in front of you. That matters because the label alone can hide what the company actually needs. The deeper question is whether the role changes customer environments and feeds learning back into the product, or whether it mainly supports selling. That is the difference between a genuine FD and a familiar role wearing a new title. A company may use the FD label because it sounds more technical or more attractive to candidates. The safer clue is the metric. If the job is judged by bookings, pipeline, or revenue, the work is probably still sales adjacent. The first test is very direct. Identify the thing the company is really paying for. Once that question is clear, the rest of the posting becomes much easier to interpret. That question cuts through the title and forces the posting to reveal its real objective. If you can answer it, you can usually tell whether the role is commercial, operational, or engineering-driven. That sounds abstract until you turn it into a search for the measured outcome. The company's reward structure usually tells you what success means. Instead of guessing from the title, read the words tied to performance and compensation. Those details usually expose the real operating model faster than the job name does. When revenue language shows up, the role is usually attached to the sales motion. Even if the posting says FD, quota, and bookings point strongly toward a solutions engineering or pre-sales function. When the scorecard is about whether the product works in the customer's environment, that is much closer to real forward-deployed engineering. The work is about shaping the system so the customer can actually use it well. Vague responsibility language is common when the title is doing more work than the description. In that case, the pay structure becomes one of the best clues you have. That is the most practical checkpoint. When the posting avoids clear responsibilities, the way the job is paid often reveals whether the company expects sales support or real engineering ownership. A quota-based package usually ties the job back to sales outcomes, even if the title sounds technical. By contrast, base salary plus equity is more common when the work is about product quality, deployment, or infrastructure rather than direct revenue conversion. That phrase matters because reward systems shape behavior. In enterprise software, variable pay usually follows sales results, while engineering roles more often reward delivery, reliability, and product outcomes. It is not a perfect law, and some companies mix the models. Even so, it is one of the quickest ways to see past the label and infer the real job shape. The naming problem usually starts with incentives. Companies often want the engineering credibility of the FD label without changing the underlying commercial role. A solutions engineer helps explain the product and support the deal team. A true FD goes further by adapting the product or surrounding system so it works in the customer's environment, then carrying that learning back inside the company. Once the job becomes harder and more technical, the title starts to look like a branding tool. The label can rise before the operating model changes. Some firms want to attract people who would ignore a classic SE posting, so they choose a more prestigious engineering label. The danger is that the new title can hide an old success metric tied to sales. That sentence captures the whole relabeling problem. A name can shift in a week, but the actual work and incentives usually tell the truth. A metaphor makes the difference easier to picture. Think about where the person sits relative to the customer's problem, selling the plan or adapting the build. A home building business gives a clean comparison because there is a clear difference between showing plans and solving build site problems. That makes the role boundary easy to see. That person is helping the sale happen. The core job is to explain, reassure, and reduce objections so the customer says yes. That person shows up when the real environment creates friction. The work is to change the design or the system so the house can actually be built where it needs to go. Both roles can be highly technical. The key difference is whether the work is upstream in the sale or downstream in the actual delivery of value. That contrast is the heart of the comparison. One role supports conversion. The other supports successful deployment in the real environment. If the work is still mainly demos and walkthroughs, the title upgrade is probably cosmetic. Real FD work changes what gets delivered, not just how it gets presented. A good way to spot the real role is to compare the situation before and after the engineer is involved. The difference shows up in what breaks, what gets fixed, and what the company learns. The posting should tell a story about a problem that existed before the role and a new capability that appears after it. That pattern is much more informative than the title alone. Before the FD enters, the product may look good in a demo, but fail in the customer's real environment. The details below show where that failure usually appears. The first clue is that the demo looks convincing on the surface. At that stage, the product has not yet had to survive the customer's actual systems or constraints. Controlled environments hide a lot of friction. Once the product leaves the lab-like setup, integration issues and workflow mismatches start to appear. That is where the real problem begins. Customer systems are messy, and a product that looks clean in a demo can fail when it meets real data, permissions, or internal tools. Even when the software technically runs, people may not use it if it fights their process. Adoption depends on fit, not just functionality. That kind of feedback is often a sign that the team does not yet have a real deployment pattern. The company knows something is wrong, but not yet how to fix it. Once an FD is involved, the work becomes less about showing potential and more about making the system usable. The measures become concrete, and the product starts to learn from the field. The first change is technical and practical. The workflow gets reshaped so the customer can actually connect it to their environment. That may mean code, configuration, or an integration layer. That is the real test. The software no longer just works in theory. It works where the customer lives and operates. Now the signal shifts from opinions to behavior. Real adoption shows up in usage patterns, completed workflows, and less manual effort. That learning loop is crucial because the deployment becomes input to future product decisions. A real FD improves one account and also informs the roadmap. A single rescue is useful, but it is not enough on its own. The stronger signal is that the engineer's work changes what the company understands about the product. That boundary keeps the role distinct. The engineer works close to the customer, but the job still connects back to what the company builds next. A checklist helps when the posting is long and the title is slippery. The goal is to read for responsibility, ownership, and reward instead of trusting the label. Line-by-line reading is useful because the hidden clues are often scattered across the description. A quick scan for key terms will usually expose the real role. This table turns the clue hunt into a simple diagnosis. Each signal points toward a likely role, and each one suggests the next question to ask before you assume the title is accurate. A few neighboring roles can look similar, so it helps to separate them carefully. That keeps the label from doing more work than the actual responsibilities. A solutions architect often comes in around delivery and implementation, especially after the sale closes. The role is about making sure the customer's deployment succeeds. An FD overlaps with that space, but with more direct engineering responsibility. That usually means modifying software, building integrations, and feeding lessons back into the product. A consultant can add a lot of value, but the work is not always hands-on ownership of the thing that reaches production. The distinction matters when you're trying to infer the real depth of engineering responsibility. A machine learning engineer can overlap with FD work when the customer problem is model heavy. Even then, the question remains whether the job is about model work alone or about solving deployment friction in a customer setting. Live postings shift quickly, so the safest method is to read the details instead of trusting one title. The same words can mean different things at different companies. A posting is a snapshot of a company's current wording, not a universal definition. Even close titles can hide different expectations, compensation, and levels of ownership. That is the safer approach because responsibility language is harder to fake than a title. The words describing what you will do tell you far more than the words in the header. A few common search terms can help you compare postings across companies. Even if the labels vary, these phrases often expose the same family of work. That phrase usually points to a customer-adjacent engineering role, but the exact scope still depends on the posting. Read the responsibilities before you decide what kind of job it is. This version often suggests stronger code ownership and production responsibility. It is worth checking whether the role is truly engineering-heavy or mostly customer-facing. That title often appears where model work meets deployment and customer needs. The important question is whether the role ships systems or mainly explains them. This one often sits on the pre-sales side. Look for demo work, technical objections, and revenue-linked measures if you want to know how commercial the role is. That title often points to delivery, architecture, or implementation support after the sale. The question is whether the role owns deployment outcomes or only advises on them. This usually signals a customer-facing technical role, but the balance can vary a lot. Some versions are closer to SE work, while others are much closer to embedded engineering. That title usually suggests hands-on delivery work. Check whether the job stops at setup or continues into code, integrations, and product feedback. This often indicates a role centered on getting software into a real environment. The strongest postings will mention production systems, integrations, or operational constraints. That phrase can hide a wide range of jobs, from sales support to deep product work. The surrounding responsibilities matter much more than the label itself. That wording often leans toward real engineering in a customer context. It is one of the better signals that the role may involve both code and direct customer interaction. That phrase usually means the company cares about fit inside existing systems. When it appears, look for ownership of actual implementation details. That term often sits after the close and before full adoption. It could be a clue that the work is about implementation success rather than initial sales motion. Side-by-side comparison makes patterns easier to see, especially when titles look almost identical. The real differences tend to show up in the experience requirements and the language around ownership. Even very similar titles can point to different work. One posting may stress customer-facing engineering, while another emphasizes software shipping and product feedback, and those differences matter. The company's wording is a primary source, so it deserves close reading. If the posting describes customer-facing engineering and shipping code into real environments, treat that as the company's claim about the role and verify it against the compensation and responsibilities. That sequence keeps you grounded. Responsibilities tell you the work, compensation tells you the incentives, and the reporting line often tells you whether the role sits near sales, delivery, or product engineering. Experience requirements can be very revealing because companies tend to be specific about the kind of person they want. Those requirements often expose the true center of gravity of the role. When a posting asks for concrete deployment or software experience, it usually wants someone who can operate in real technical environments. That is a stronger engineering signal than generic support language. A direct customer-facing requirement means communication is part of the job, not an occasional extra. That can exist in FDE roles, but it also appears in more sales-adjacent roles, so you still need more context. Travel and on-site work usually mean the role is tied to the customer environment. That is often a sign of deployed engineering, but the rest of the posting should confirm it. Industry specialization matters because some roles are really domain translators. The question is whether that specialization comes with real technical ownership or just subject matter support. That distinction is one of the clearest lines to draw. Owning code means shipping a technical artifact. Owning presentations means helping explain or sell the artifact. Roadmap influence is a strong clue that the work feeds back into the company's product direction. When that is present, the role is much closer to the forward deployed model. If the role is really tied to revenue motion, the posting usually says so directly. If it is truly forward deployed, the description will lean toward implementation ownership, adoption, and lessons that shape the product. The same posting should lead different readers to one practical conclusion. Hire for the bottleneck, evaluate for the accountability, and protect yourself by reading beyond the title. A founder should ask what is actually blocking growth. If sales conversion is the bottleneck, SE capacity matters. If implementation and learning are the bottleneck, FD capacity matters. If delivery after the close is the bottleneck, an SA may be the right fit. A recruiter can use that question to cut through vague language fast. The answer usually reveals whether the job is mislabeled or whether the title really matches the work. A job seeker should not be distracted by polished terminology. The useful clues are the metric, the compensation model, and the boundary of what the role actually owns. Those three clues together tell the story. What the company rewards, what you own, and what changes after your work are a much better test than the title alone. That instinct becomes even easier to use when the roles are placed side by side. A comparison table will make the differences much sharper and quicker to read. This comparison table separates roles that sound similar but do very different jobs, so hiring decisions get anchored to outcomes instead of titles. Those titles overlap in language, but the work underneath them is not the same. The useful question is not which one sounds technical enough. It is which one ships product, which one advises, and which one owns the customer result. That role sits on the path from a working demo to a real deployment. The job is judged by whether the customer actually adopts the system, not just whether the model or integration look good in a notebook. That home building analogy keeps the boundaries clear. One role designs the plan, another validates the approach, another advises from the outside, another builds the core system, and the FD handles the messy last mile where everything has to work together for real users. A strong team often needs all of these roles at once, because each one covers a different part of the delivery chain. The cost comes when the title is mistaken for the job. Then the hire is optimized for the wrong kind of success. These roles all sit near customers, but they carry different ownership, different coding depth, and different success metrics. The table separates them by the problem each role is responsible for solving, which is the fastest way to avoid confusing title with function. Compensation signals vary a lot by company, level, and geography, so the table should be read as a guide rather than a rule. If pay matters for a hiring decision, live postings and current market data are the safer reference. Each column answers a different question. Who owns the work, how technical the role is, how it is usually paid, where it sits in the customer life cycle, and how success gets measured. Read across a row and the pattern becomes much clearer than any single title by itself. The trap is assuming that similar customer contact means similar responsibility. The next lines separate the roles by ownership, so the same customer can appear in several rows without those jobs being interchangeable. A single customer can involve sales, architecture, delivery, and post-sale support, but each role touches a different part of the problem. The useful question is not who talks to the customer, but what outcome that person is accountable for. An FD is not just making software run. The job is to make it usable in the real environment. That means the customer can adopt it, integrate it into daily work, and get value from it without the deployment falling apart. An SE proves that the product can solve the problem before the deal closes. Demos, trials, and proof of concepts matter here because the goal is to remove technical doubt and help the buyer move forward. A solutions architect focuses on whether the overall design makes sense and whether the technical risks are manageable. The work is less about building every piece and more about making sure the shape of the solution will hold up. After launch, the question changes from can we sell or build it to can we keep it healthy? That is where TAMs and customer engineers spend their time. Escalations, continuity, and preventing problems from turning into churn. Consultants are accountable for framing the problem, recommending a path, and often guiding the work to completion. The exact mix depends on the firm, but the core value is disciplined advice that turns into managed progress. An ML engineer is responsible for the model as a product component, not just for writing code around it. Training, evaluation, deployment, and pipeline reliability all have to work together if the system is going to perform in production. Before the FD steps in, teams often have something that looks promising but breaks in the real environment because the data is messy, the workflow is awkward, or the integration is fragile. Once the FD starts working, the system gets adapted to real usage, and the important question becomes whether customers are actually getting value from it. Good deployment work leaves behind structure that other people can maintain, documentation, repeatable steps, and product feedback that improves the system itself. The aim is either a clean scale-up or a clean handoff, not a single person becoming the only way the customer can keep moving. An FD's value becomes clearest in a real customer workflow, where the model has to survive messy inputs, existing tools, and production constraints. A useful example is a mid-market operations team trying to automate document triage. The buyer is not asking for a toy demo. They want something that helps real staff handle real work faster. The prototype often looks fine in a controlled environment because the inputs are neat and predictable. Production changes the picture. Scanned PDFs, email attachments, and inconsistent formats create failure points that never showed up in the demo. An FD starts by turning the customer's actual workflow into the design target. That shifts the work from a narrow model demo to a system that can handle intake, cleanup, and delivery end to end. The first issue is mismatch. A solution can look correct in testing and still fail where people actually use it. If the lab environment is cleaner than the real one, the prototype is only proving that the model can perform under ideal conditions. The engineering job is to connect the messy front end to the business system at the back end. That means handling file intake, normalizing the data, and making sure the result lands where the team already works. Success is not just technical correctness. The real test is whether staff rely on the output, whether it saves time quickly enough to matter, and whether the deployment stays steady as volume grows. Every deployment also becomes a source of product knowledge. The team learns which document types break the flow, where users get stuck, and which integration pattern is worth turning into a repeatable product feature. That is the practical difference. The goal is not a model that merely functions in isolation, but a system that fits the customer's environment, tools, and daily habits. The T-shaped skill model explains why an FD needs both depth and range. Strong expertise in one technical area, plus enough breadth to work across product, customer, and engineering conversations. The vertical part of the T is the specialist skill that lets the person solve hard technical problems. The horizontal part is the broader fluency that makes it possible to talk to customers, judge product trade-offs, and understand the rest of the system well enough to collaborate effectively. That is why the role can feel like full-stack implementation, even when it is not web development. The scope reaches from what the user needs all the way through the data, the application logic, the integrations, and the feedback loop that shows whether the solution is working. The strongest FDs can translate without distorting the problem. They keep the customer's intent, the product team's goals, and the engineering constraints aligned, so the team solves the same issue from the same understanding. Role titles and job descriptions often reveal the real shape of the work. The goal here is to spot postings that sit near product, deployment, and customer work, not just read the title at face value. A title can be broad or even misleading, so the body of the posting has to confirm what the job actually involves. The combination tells you whether the role is truly technical, customer-facing, or closer to sales support. Forward deployed engineer usually signals someone working close to a customer's environment, often with real implementation responsibility. The phrase suggests technical work that happens where the product is being used, not only inside a lab or roadmap team. This version keeps the same idea, but makes the software side explicit. It often points to an engineer who is building, adapting, and deploying software in direct response to customer needs. Solutions engineer roles often sit between technical depth and customer communication. The work may involve demos, integration help, and shaping the product to fit a specific use case. Solutions architect usually means designing the technical shape of a deployment or system. The emphasis is often on making pieces fit together cleanly for a customer rather than writing features in isolation. Customer engineer strongly suggests a role built around direct customer work. Expect troubleshooting, integration, and technical guidance that helps the customer get value from a product. Technical account manager is often a post-sales role with both relationship management and technical ownership. The job may focus on keeping customers successful after the sale, especially in complex deployments. Consultant is broad, so the body matters even more. In this context, it can mean implementation, process change, or technical advising, depending on how much hands-on delivery the posting describes. Machine learning engineer is a strong signal when the posting mentions deployment, experimentation, or production systems. The important question is whether the work stays at model development or extends into operating the model in practice. Applied AI engineer usually points to using AI in a real product or workflow, not just researching algorithms. That often means integration, evaluation, and turning AI capabilities into something customers can actually use. Keyword matching works best when it reflects the work, not just the title. These phrases are useful because they expose whether the role is about customer delivery, system integration, or technical ownership. Customer deployment points straight toward getting software or systems live in a real environment. That usually means the role cares about setup, adaptation, and successful rollout. Production implementation suggests the work must survive real usage, not just look good in a demo. It often implies practical engineering under real constraints. Technical ownership means someone is expected to carry the solution beyond a handoff. That is a useful signal for roles where accountability matters after the initial sale or setup. Post-sales work happens after the deal closes, so it usually centers on adoption, support, and deployment success. That is different from pure product engineering or pure sales. Pre-sales roles support the buying process, often through demos, technical validation, and solution design. The engineer is helping win trust before the customer signs. Integration tells you the role has to make separate systems work together. That usually requires both engineering skill and an eye for how the customer's environment is already set up. Workflow automation often means building tools that reduce manual steps in a business process. In job postings, it can signal practical problem solving more than abstract feature work. Data wrangling points to cleaning, shaping, and preparing data so the system can use it. When this shows up, the job may involve a lot of hands-on, messy technical work. Cross-functional means the role sits between teams, so communication matters as much as technical execution. That usually appears in jobs where engineering has to coordinate with sales, product, or delivery. Customer-facing engineering is one of the clearest signals that the work is close to the user and the account team. Expect direct interaction, fast feedback, and technical work shaped by customer needs. Time to value measures how quickly the customer gets useful results. When a posting uses that phrase, The role is usually tied to implementation speed and practical outcomes. Those four checks help separate a true deployment-oriented engineering role from a sales-heavy title. Once you know who pays the person, what experience they want, what they own, and where they sit in the customer lifecycle, the posting becomes much clearer. Quota language usually leans toward sales-adjacent work, while base plus equity without quota often points more toward engineering. Then look for customer-facing history, integration, scripting, ML deployment, or on-site problem-solving, and ask what the role still owns after the customer says yes. Words like closing deals, forecast attainment, and pipeline are strong signs that revenue generation is central to the job. When the posting talks instead about adoption, reliable deployment, and feedback from real usage, the role is much closer to the forward-deployed engineering center of gravity. A useful test is simple. What outcome does the company reward most? If the praise goes to winning the meeting, the role is probably supporting sales. If the praise goes to changing production behavior, the role is much closer to hands-on deployment engineering. A hiring decision becomes much easier when it starts from the bottleneck, not the job title. The point here is to match the kind of customer problem with the role that can remove it. A founder does not need a perfect org chart. A founder needs a rule that turns customer friction into staffing choices. That rule tells you where capacity is actually missing. When the sale depends on explaining the technology clearly enough to unlock trust, the gap is pre-sales technical support. More SE coverage helps because the obstacle is understanding, not implementation. Sometimes the buyer already wants the product, but the shape of the solution is still unclear. In that case, solution architects matter because they turn a vague need into a workable design before anyone builds. At this stage, the challenge is no longer the pitch or the design. The real test is whether the system survives the customer's messy environment, and that is where forward-deployed engineering earns its keep. When the product itself depends on model performance, the pressure shifts inside the machine learning stack. You need engineers who can improve the models and keep the pipeline healthy, not just people who can explain the result. Some customers want expertise plus execution wrapped together. A consultant fits when the value is partly judgment, partly delivery, and the relationship is meant to carry the work forward. Launch is not the end of the relationship if adoption, retention, or expansion still depend on technical support. At that point, the role is about keeping the account healthy after the initial deployment is done. That is the cleaner way to think about hiring. Do not start from the name of the role. Start from the obstacle that is slowing the customer outcome. Then pick the person who removes it. All of these roles can look similar from far away, but they differ in where they act and what they are responsible for. The useful comparison is who keeps ownership once the idea has to survive contact with the real customer. The next step is to separate two kinds of FDE work: the moments when it pushes the product forward and the moments when it is still mainly making deployment succeed. That boundary is where the role starts to blur with product.